iron core solidified, creating an incredibly dense heart, a feature that would make Mercury unique among the rocky planets. Gradually, the fiery chaos began to settle. The surface cooled, hardening into a crust marked by towering ridges and jagged cliffs. The planet's early atmosphere, thin and tenuous, was stripped away by the sun's relentless solar wind, leaving Mercury exposed to the vast emptiness of space. Its small size and proximity to the sun ensured that it could never hold onto an atmosphere for long. What remained was a world of stark contrasts. Scorching heat on one side, freezing cold on the other. Today, Mercury continues its silent journey around the sun, the closest of all planets to the brilliant star at the center of our solar system. Its surface is a map of time, marked by the scars of its turbulent formation. Vast plains stretch across its face, interrupted by towering cliffs formed as the planet cooled and contracted. Craters of all sizes reflect the violent history of its early years, each one a reminder of the forces that shaped it. Now, imagine yourself drifting closer to this ancient world. You float above its cratered surface, bathed in the harsh light of the sun. The airless silence is absolute, and the only sound is the gentle rhythm of your own breathing. You feel the warmth of the sunlight on one side of your body, while the other remains in the shadow of the planet, a place of eternal cold. The contrast is soothing, a balance of extremes. As Mercury rotates slowly, you notice the play of light and shadow across its surface. Days and nights here are long, each lasting nearly 59 Earth days. The sun appears enormous in the sky, rising and setting in slow, deliberate arcs. You let the steady pace of this ancient rhythm calm your mind, grounding you in the timeless dance of the cosmos. The planet's dense core, deep beneath its surface, still radiates faint warmth. It is a quiet reminder of the energy that forged Mercury in the fires of the early solar system. Above, the sun continues to shine, a constant source of light and life, its gravity keeping Mercury locked in its orbit, eternally circling. As you float above this small, resilient world, you feel a deep connection to its history. Mercury's story is one of endurance, a testament to the forces that shaped the solar system. It has survived billions of years, silently bearing witness to the passage of time. In its stillness, you find peace, a reminder that even in the vastness of space, there is balance, order, and beauty. Let your thoughts drift like the dust that once formed this planet. Let the warmth of the sun and the cool shadow of space guide you into a deeper state of relaxation. Breathe in the timelessness of the cosmos and exhale all the worries of your day. Mercury, the smallest and innermost planet, continues its quiet journey, just as you now drift into the soft embrace of sleep. Mercury's orbit is an elliptical path, slightly stretched, bringing it close to the sun at one point and farther away at another. This orbit creates a unique pattern of light and shadow on its surface, a dance of illumination that repeats endlessly over time. The sun, as seen from Mercury, doesn't behave as it does from Earth. Instead, its path in the sky is irregular, rising and setting in strange, looping patterns. This is due to Mercury's slow rotation and its gravitational interactions with the sun, a phenomenon that scientists call spin-orbit resonance. Imagine yourself standing on Mercury's surface, gazing at this celestial display. The sun looms 3 times larger in the sky than it does on Earth, and its light is almost blinding. The surface beneath your feet is dry and rocky, covered with fine, powdery dust formed by countless impacts over billions of years. There is no air to carry sound, no wind to stir the dust, only the profound stillness of a world untouched by life. As the sunlight fades and night begins to fall, the temperature drops rapidly. Mercury's lack of atmosphere means there is nothing to retain the heat of the day. Within moments, the surface cools, plunging into freezing darkness. But the beauty of the night sky above is breathtaking. With no atmosphere to obscure the view, the stars shine with incredible clarity, filling the sky with a tapestry of light. Mercury's surface tells a story of its past. The enormous Caloris Basin, one of the largest impact craters in the solar system, stretches over 1,500 kilometers across. This scar, formed by a massive collision billions of years ago, is surrounded by rings of mountains and plains filled with solidified lava. It is a reminder of the planet's violent youth, when impacts like this one were common throughout the solar system. Beyond the craters, vast plains stretch to the horizon, marked by ridges and cliffs known as scarps. These formations were created as the planet cooled and contracted, causing the crust to buckle and fold. Some of these scarps are hundreds of kilometers long, towering over the surrounding terrain like ancient walls. Mercury's core, which makes up a significant portion of its mass, is still slightly molten. This creates a weak magnetic field, a remnant of the planet's once dynamic interior. It is faint, but it is there, a quiet echo of the forces that shaped this small world. The sun begins to rise again, its light creeping slowly across the surface, bringing warmth to the frozen landscape. The cycle repeats, a steady rhythm that has continued for billions of years. Mercury's rotation is so slow that a single day lasts longer than its year. This creates long periods of light and dark, each lasting weeks, a contrast that shapes the planet's character. Drifting above the surface, you feel a sense of calm. Mercury's story is one of resilience, a world that has endured the extremes of heat and cold, of light and dark, for longer than we can truly comprehend. Its proximity to the sun has made it a place of extremes, but also a place of incredible beauty. Allow yourself to float, to be carried by the quiet rhythm of Mercury's orbit. The sun's light glints off the planet's rocky surface, illuminating the craters, the ridges, the vast empty plains. Each feature is a testament to the forces of nature, to the quiet strength of a world that has stood the test of time. Let your breathing slow as you picture this scene. Inhale the vastness of space, exhale the weight of your thoughts. Imagine the gentle pull of gravity holding you close, the soft light of the sun warming you. The silence of Mercury becomes your silence. The stillness of the planet becomes your stillness. As the sun rises higher, Mercury's surface begins to shimmer with heat. The rocks, which had been frozen solid during the night, expand and crack under the intense heat of the day. The temperature on the sunlit side climbs to over 400 degrees Celsius, while the shadowed side remains locked in frigid darkness. This stark contrast defines the planet's character, a balance between extremes that has existed for eons. Now imagine yourself moving across the surface, floating above the jagged ridges and craters. You come across a feature known as the hollows, mysterious, shallow depressions scattered across the landscape. These bright, reflective areas are unique to Mercury, likely formed by the evaporation of volatile materials under the relentless heat of the sun. Their shimmering surfaces seem to glow, like pools of light amidst the dark, rocky terrain. As you drift further, you notice something remarkable: the traces of Mercury's magnetic field. Though weak, it creates faint, invisible lines that encircle the planet, a reminder of its molten core deep beneath the surface. This magnetic field interacts with the solar wind, streams of charged particles flowing outward from the sun occasionally. These particles strike the surface, creating a subtle glow of energy, an aurora-like phenomenon in the absence of an atmosphere. You float higher, and the horizon curves beneath you. The vast, barren landscape stretches endlessly in every direction, bathed in the harsh brilliance of sunlight. This is Mercury, a world that has witnessed the birth and evolution of the solar system. Every crater, every ridge, every shadowed valley tells a story of time, of patience, of endurance. Now picture the young sun, billions of years ago, shining with even greater intensity than it does today. Mercury, then newly formed, was a fiery world, its surface covered in molten rock and flowing rivers of lava. Over time, this fiery chaos cooled, and the planet solidified into the rocky sphere you see now. The sun, too, has aged, its light softening slightly over the millennia, but its bond with Mercury remains unbroken. As the sun begins to set once more, the long shadows stretch across the ground, creating intricate patterns on the surface. The day ends slowly, the temperature falling with every passing moment. The stars begin to emerge in the sky, one by one, until the night is filled with their ancient light. Mercury's surface glows faintly under the starlight, a quiet reminder of its timeless journey. In the stillness of this moment, you feel the peace of Mercury's rhythm. The planet spins slowly, completing its day in silence, unaffected by the passing of time. You let this rhythm guide your breathing, slow and steady, like the orbit of a planet, like the rise and fall of the sun. The sun has fully set now, and Mercury's surface is plunged into a deep, quiet cold. The temperature plummets to nearly minus 180 degrees Celsius, and the rocks contract once again, their surfaces cracking softly in the absolute silence of space. Without an atmosphere to carry sound, there is no echo, no whisper, only the profound stillness of a frozen world. Above you, the stars shine brighter than ever, their light unfiltered by any haze or clouds. The constellations seem clearer, more vivid, like ancient maps etched into the cosmos. Among them, the Milky Way stretches like a river of light, a reminder of the galaxy's vastness and your place within it. You drift along the surface, passing over the immense Colorus Basin. Its edges rise like frozen waves, a testament to the colossal impact that created it billions of years ago. The energy from that collision was so immense that it rippled through the planet, fracturing the surface on the opposite side. The planet bears these scars like a memory, etched into its crust for eternity. As you move further, the terrain begins to change. You see regions of smooth plains, likely created by ancient volcanic activity. These plains stretch like seas of stone, their surfaces cracked and weathered by billions of years of exposure to the sun's relentless heat. Here and there, smaller craters interrupt the smoothness, each one a snapshot of a moment in time when the universe collided with Mercury's surface. You notice the sharp cliffs once again, known as lobate scarps. These ridges are like wrinkles on the planet's surface, formed as Mercury's core cooled and contracted over time. Some of these cliffs are immense, rising several kilometers high and stretching for hundreds of kilometers. They are ancient geological features, unchanging and eternal, silent witnesses to the passage of time. As you float higher, you notice something peculiar: the slight wobble of Mercury's orbit. Known as precession, this slow shift in Mercury's path was once a mystery. It wasn't until Einstein's theory of general relativity that scientists understood this phenomenon, a subtle effect of the sun's immense gravity bending space and time itself. Mercury, small and unassuming, played a crucial role in revealing the universe's hidden laws. Time feels meaningless here on this ancient world. A single day on Mercury lasts 176 Earth days, and a year is only 88 days. The sun rises and sets in strange, looping motions, a slow, deliberate rhythm that seems almost meditative. You let this rhythm guide you, your breathing synchronized with the planet's timeless orbit. The night deepens, and the cold intensifies, but the beauty of the stars keeps you warm. Each point of light is a reminder of the universe's vastness, of the countless other worlds spinning silently through space. You feel a connection to all of it, a sense of belonging in this endless expanse. As you continue to drift, the sun begins its slow ascent once more. The faintest hint of light touches the horizon, casting a soft glow across the surface. The shadows retreat, and the rocks begin to warm again. The cycle starts anew, an unbroken pattern of light and dark that has defined Mercury for billions of years. You let yourself be carried by this cycle, by the gentle pull of the planet's gravity and the steady rhythm of its orbit. The silence of Mercury becomes your silence. The stillness of space becomes your stillness. You are part of the cosmos, connected to its ancient, unchanging dance. The sun rises slowly, painting the rugged terrain of Mercury in hues of gold and deep shadow. The craters, once hidden in darkness, now reveal their intricate details, steep walls and central peaks formed by the immense forces of impacts long past. Each ray of sunlight gliding over the surface seems to awaken the planet's history, as if whispering the secrets of its creation. The surface begins to radiate heat again, and the rocks expand under the sun's intense glare. Mercury's day side becomes an inferno, while the night side remains frozen, a stark contrast that has existed since the planet first formed. You sense the balance in these extremes, the way they coexist without conflict, shaping Mercury into the world it is today. You pass over a smaller impact crater, its edges sharp and well-defined. The rays of lighter material surrounding it spread outward in brilliant patterns, evidence of a relatively recent impact. Recent in planetary terms, meaning perhaps 1,000,000 years ago. Time here moves differently, each moment stretched across eons, giving every feature a sense of permanence. Looking closer, you notice small patches of brightness scattered across the darker surface. These are the hollows again, enigmatic and otherworldly. Scientists believe they are formed by the sublimation of volatile materials, exposed to the unyielding heat of the sun. Their strange, reflective surfaces make them stand out like jewels embedded in Mercury's rocky crust. Farther along, you come across the massive cliffs once more. These scarps, towering and ancient, are among the most striking features of the planet. As Mercury's interior cooled and contracted, the crust buckled, creating these immense ridges. They rise above the plains like the spines of a slumbering giant, quiet but powerful, reminders of the forces that shaped this world. Floating higher, you take in the planet as a whole. Mercury is small, barely larger than Earth's moon, but its dense core makes it incredibly heavy for its size. You can almost feel its gravity, faint but steady, anchoring it to the sun's immense pull. This closeness to the sun defines Mercury, subjecting it to solar winds and radiation that sculpt its surface and atmosphere, or lack thereof. Mercury's orbit is another unique aspect of its character. The planet is locked in a 3:2 resonance with the sun, completing 3 rotations on its axis for every 2 orbits around its star. This means that a single sunrise takes an entire year to complete, creating an unhurried rhythm that feels almost meditative. The sun's light moves slowly across the surface, and you let yourself be carried by this deliberate pace, your thoughts slowing to match it. You drift into Mercury's thin exosphere, a tenuous layer of atoms and particles ejected from the surface by the solar wind. Sodium, potassium, and other elements form a faint glow around the planet, invisible to the naked eye but detectable by instruments. This exosphere is fragile, constantly replenished by micrometeoroid impacts and the sun's relentless energy. Above, the sun dominates the sky, its light so intense that it seems to saturate the very fabric of space. Its gravitational pull keeps Mercury tightly bound, its radiation constantly reshaping the planet's surface. Yet Mercury endures, resilient and unwavering, circling its star in an endless, graceful ellipse. The sun begins to set again, and the long shadows stretch out over the surface once more. The planet's rotation is so slow that the transition between day and night feels eternal, a gradual shifting of light and darkness. As the horizon darkens, the stars emerge once more, filling the sky with their ancient light. You let yourself sink deeper into this rhythm, the unchanging cycle of day and night, of light and shadow. Mercury's journey around the sun is a reminder of the constancy of the cosmos, of the quiet strength that comes from enduring the passage of time. You feel a sense of peace in this stillness, a connection to the planet's ancient story. As the stars reclaim the sky, Mercury's surface seems to fall into a deep slumber, its timeless stillness undisturbed by winds or weather. The shadows grow deeper, pooling in the craters and valleys, and the planet once again becomes a world of contrasts. The sun's absence brings with it a quiet, profound cold that seeps into the very rocks, causing them to contract and crack in the silence of the vacuum. Far above the surface, the faint glow of Mercury's exosphere becomes more apparent. Microscopic particles, energized by the sun's radiation, drift in an ethereal halo around the planet. These particles, cast off from the surface and carried into space, form a connection between the world below and the vastness beyond. It is as if Mercury breathes, exhaling fragments of itself into the cosmos, a subtle and ancient exchange. You float over the vast Colorus Basin again, its sheer size impossible to grasp fully from this distance. This scar of a long-forgotten impact speaks of unimaginable forces, a single event that forever changed the planet's surface. The surrounding terrain, rippled and fractured by the energy of that collision, stretches outward like a frozen wave, a record of a moment in time when the young solar system was a place of chaos and creation. Moving beyond the basin, you encounter vast plains, smooth and featureless in contrast to the jagged cliffs and rugged craters. These plains were shaped by volcanic activity in Mercury's distant past, when its interior was still molten and alive. Rivers of lava once flowed across these regions, filling low-lying areas and creating expansive fields of basalt. Now solidified, these plains reflect the light of the distant stars, their dark surfaces shimmering faintly in the cold. Mercury's rotation is imperceptible, so slow that it feels as if the planet itself is pausing to let you take in its story. Days and nights stretch endlessly here, the passage of time measured not in hours or minutes but in the steady orbit of the planet around its star. You feel yourself syncing with this rhythm, your thoughts slowing to match the unhurried pace of Mercury's existence. As the night deepens, you find yourself over one of the planet's mysterious polar regions. Though most of Mercury is barren and lifeless, the deep craters near its poles hold a secret, pockets of water ice, hidden in perpetual shadow. These regions, untouched by the sun's heat, are like time capsules, preserving materials that may have existed for billions of years. The ice glistens faintly, a reminder that even in the harshest environments, traces of something unexpected can endure. Floating higher now, you see Mercury as a whole, small, dense, and ancient. Its surface, marked by countless craters and cliffs, is a testament to its resilience, a world that has withstood the extremes of heat and cold, light and shadow, for eons. The sun's light outlines its curves, creating a luminous halo that seems to radiate strength and peace. You let yourself drift in this moment, cradled by the quiet strength of Mercury's presence. The silence becomes your silence, its endurance becomes your own. The planet's slow rotation and steady orbit remind you that there is no need to rush, that time flows in its own way, unhurried and infinite. The stars above seem closer now, their light steady and calming. The Milky Way stretches across the sky, a vast river of light that connects all the worlds of the solar system. You feel a part of this endless expanse, a small but significant piece of the universe's story. As the sun begins its slow return, you sense the warmth creeping back across Mercury's surface. The rocks, frozen and still, start to expand once more, and the shadows retreat before the advancing light. The cycle continues, unbroken and eternal, a reminder of the planet's steadfastness in the face of change. You take one last breath, letting the rhythm of Mercury guide you. The silence of the planet, the balance of its extremes, the constancy of its orbit, all of it lulls you into a deeper state of peace. You are a part of this timeless story, a witness to the quiet beauty of a world that has endured for billions of years. The first rays of sunlight crest the horizon, piercing the darkness and illuminating Mercury's ancient surface once more. The craters, valleys, and scarps gradually emerge from shadow, their edges sharp and clear under the sun's unfiltered light. The planet's surface begins to warm, expanding after the cold stillness of the night, and the stark contrasts between light and dark return, defining Mercury's rugged beauty. The sun, so immense and brilliant from this close distance, seems to dominate the sky, casting its golden light across the barren terrain. The slow rotation of Mercury means the sunlight spreads lazily, creeping inch by inch over the rocks and plains, revealing details that were hidden in the shadow of night. You drift with this light, letting its steady advance calm your thoughts. As the day progresses, the temperature rises rapidly, transforming the surface into a scorching landscape. Yet, even in this intensity, there is tranquility. The silence remains absolute, the airless environment ensuring that no sound disturbs the planet's serenity. The heat, while overwhelming, feels distant from your vantage, as though you are merely a quiet observer of this eternal cycle. Far below, you notice the shimmering effect of the sunlight reflecting off the hollows. These enigmatic features, unique to Mercury, glint like scattered gemstones across the planet's dark surface. Their origin remains a mystery, a reminder that even in a world as ancient and well-studied as Mercury, there are secrets waiting to be uncovered. The hollows, bright and reflective, seem alive, as if Mercury itself is quietly resisting the sun's relentless pull. Your journey takes you toward Mercury's equator, where the planet's slow spin reveals a landscape rich with contrasts. Smooth plains, likely formed by ancient lava flows, stretch into the distance, interrupted by the jagged cliffs of the scarps. These scarps, some rising kilometers high, are silent witnesses to the planet's cooling and contraction over billions of years. They speak of a world that has endured unimaginable forces, reshaping itself as it settled into its final form. High above the surface, the faint exosphere of Mercury glows with particles cast off by the sun's solar wind. Sodium and potassium atoms, energized and glowing faintly, drift in a halo around the planet. This exosphere is fragile, constantly replenished and eroded, but it is also a testament to Mercury's dynamic relationship with its star. You imagine the solar wind brushing against the planet, like an invisible river of energy flowing through the solar system. As the sun climbs higher in the sky, the play of light and shadow across the surface becomes even more dramatic. The craters cast long, sharp shadows, while the ridges and scarps stand out in stark relief. This interplay creates a world of textures, a landscape carved by time and shaped by extremes. The sun's heat intensifies, and you feel the relentless power of the star that governs Mercury's existence. And yet, there is peace here. The stillness of Mercury, its unchanging rhythm, offers a sense of calm. The planet's surface, though battered and scarred, has remained steadfast through billions of years. Its journey around the sun is quiet and deliberate, a reminder that even in the face of immense forces, there is strength in endurance. You let yourself drift higher now, gazing down at Mercury from above. The planet appears small and solitary, but also incredibly resilient. It orbits the sun with quiet determination, its dense core anchoring it firmly in place. The sunlight glints off its rocky surface, a beacon of light in the vast darkness of space. As the sun begins its slow descent, the shadows lengthen once more, creeping across the surface and covering the planet in a blanket of darkness. The temperature drops, the heat of the day giving way to the freezing cold of night. The cycle continues, unbroken and eternal, a rhythm that Mercury has followed since its creation. You feel yourself drawn into this rhythm, your breath slowing to match the planet's steady pace. The silence of Mercury becomes your own silence. The stillness of the planet becomes your own stillness. The light fades, the stars reappear, and the night takes hold once again. As night envelopes Mercury once more, the surface plunges into the quiet chill of space. The warmth of the day is gone, leaving the rocks frozen in their stillness. The shadows deepen, and the craters that were so vivid in the sunlight now dissolve into the darkness, their edges barely visible under the faint starlight. The temperature plummets, the surface contracting ever so slightly, as if the planet itself is taking a slow, deliberate breath. Above, the stars dominate the sky. Without an atmosphere to obscure them, they shine with an unmatched brilliance, each one a distant sun in its own right. The Milky Way stretches out as an infinite river of light, its soft glow connecting the vastness of the cosmos. For a moment, you feel the enormity of space, yet within it, Mercury's quiet presence feels like an anchor, a small, steadfast world orbiting its star in silent perseverance. You glide toward the polar regions, where shadows linger even during the day. Here, in craters that have never seen the sun's light, lie patches of ancient ice. Locked away in these perpetual shadows, the ice has remained untouched for billions of years, a remnant of a time when the solar system was young and chaotic. The contrast between this frozen water and the fiery extremes of the rest of the planet is striking, a paradox that speaks to Mercury's unique nature. These polar craters are serene, their icy floors glistening faintly in the dim light reflected from distant stars. They are places of stillness, timeless and undisturbed, offering a glimpse into the earliest days of the solar system. You imagine the comets that brought this water to Mercury, colliding with its surface in a burst of energy, leaving behind these frozen traces of their journey. As you float higher, the entirety of Mercury comes into view once more. Its surface, so scarred and rugged, tells the story of a world that has endured more than most. The craters, the scarps, the plains, they are all chapters in Mercury's long history, a testament to the forces that shaped it. Despite its small size and its proximity to the Sun, Mercury has held its ground, remaining steadfast in the face of immense challenges. The Sun, though hidden below the horizon, still exerts its influence. Its gravitational pull keeps Mercury in its tight orbit, and the solar wind continues to brush against the planet, sculpting its exosphere and reshaping its surface. This invisible connection between the Sun and Mercury is a quiet dance, a balance of forces that has endured for billions of years. Time seems to stretch here, each moment blending into the next. A single day on Mercury is so long that it feels eternal, the slow rotation of the planet offering a sense of timelessness. You find comfort in this unhurried rhythm, allowing your thoughts to slow and settle, as if syncing with the planet's deliberate pace. As the stars shine above, you feel a deep sense of calm. Mercury's story is one of endurance, a reminder that even in the harshest conditions, there is beauty and strength. Its surface, though battered and scarred, reflects a quiet resilience, a testament to the power of persistence and balance. The faint glow of Mercury's exosphere becomes more noticeable as your perspective shifts. Particles of sodium and potassium, released by micrometeoroid impacts and the Sun's energy, drift gently around the planet, creating a delicate, shimmering halo. This exosphere is fragile, constantly replenished and eroded, yet it endures, a subtle connection between the planet and the cosmos. You allow yourself to drift with this halo, feeling its quiet energy and its connection to the Sun's distant warmth. The stillness of Mercury's night surrounds you, a blanket of peace that seems to stretch infinitely. The cycle of day and night, of light and shadow, continues as it always has, unbroken and eternal. As the horizon begins to lighten with the approach of dawn, you feel the first faint hints of warmth returning to the surface. The Sun, still hidden, begins to announce its presence, its light creeping slowly across the landscape. The stars begin to fade, their brilliance overtaken by the growing glow of the Sun. You let this transition guide you, your breathing steady and slow, your thoughts quiet and calm. Mercury's timeless rhythm carries you, its silence and stillness becoming your own. The light returns, the cycle begins anew, and you find peace in the endless balance of this ancient world. The first light of dawn stretches across Mercury's surface once more, creeping slowly over the rugged terrain. The jagged cliffs of the scarps catch the sun's rays first, their peaks glowing like molten gold against the dark expanse. The light spreads, filling the craters and valleys with warmth, chasing away the chill of the long, frozen night. Slowly, the surface comes alive again, as if awakened by the sun's gentle touch. You hover above this transformation, watching as the planet reveals itself anew. Each crater, each ridge, each plain becomes distinct, bathed in the sharp clarity of unfiltered sunlight. Mercury's surface, though scarred and battered, seems to glow with resilience. The ancient rocks, having endured countless cycles of heat and cold, reflect the light with a quiet dignity. As the sun rises higher, the temperature begins its relentless climb. The rocks expand, cracks forming and deepening under the intense heat. The stark contrast between day and night is part of the planet's identity, a balance of extremes that has defined its existence for billions of years. You feel the power of the sun's presence, its energy shaping and reshaping Mercury's surface with every passing moment. Drifting closer, you notice the fine dust that blankets much of the surface. This regolith, formed by countless impacts over the eons, is a testament to the planet's history. Each grain of dust carries the story of a collision, a fragment of the universe's past embedded in Mercury's skin. The surface is silent, untouched by wind or rain, preserving every detail as if frozen in time. You move toward the Calorus Basin once more, its immense size and complexity captivating. The basin, formed by an ancient impact, is surrounded by concentric rings of mountains, their peaks rising like ripples frozen in stone. Within the basin, smooth plains stretch outward, remnants of lava flows that once filled the crater. The energy of the impact that created this feature was so immense that it sent shockwaves through the entire planet, creating a chaotic pattern of fractures on the opposite side of Mercury. Beyond the basin, you find smaller craters, their sharp edges indicating that they are more recent. The rays of ejected material spread outward like frozen explosions, their patterns intricate and mesmerizing. Each crater tells a story, a moment when the universe touched Mercury, leaving a lasting impression on its surface. You let your gaze shift toward the sun, now high in the sky. Its light dominates everything, overpowering the stars and casting long, stark shadows across the planet's surface. From Mercury, the sun appears immense, its fiery brilliance both life-giving and destructive. The heat it radiates is intense, and yet Mercury endures, orbiting faithfully, unyielding in its path. The slow rotation of the planet creates an unusual rhythm. Daylight stretches on for weeks, the sun moving gradually across the sky. The pace is deliberate, almost meditative, a reminder that time flows differently here. You feel yourself sinking with this rhythm, your thoughts slowing, your breathing steady, as if you are part of the planet's unhurried cycle. As the day progresses, the heat intensifies further, transforming the surface into a searing landscape. Yet even in this harsh environment, there is beauty. The bright hollows, scattered across the plains, reflect the sunlight like tiny mirrors, their origins still a mystery. These features, unique to Mercury, add an element of intrigue to its ancient surface, a reminder that even the most studied worlds hold secrets. You drift higher again, looking down at the planet as a whole. Mercury appears small and solitary, yet its dense core and enduring surface give it an undeniable strength. It is a survivor, having withstood the extremes of the sun's energy and the chaos of the early solar system. Its orbit is steady, its rhythm constant, a quiet testament to the resilience of the cosmos. The sun begins its slow descent, and the shadows lengthen once more. The surface, so bright and scorching just hours before, begins to cool as the light fades. The transition from day to night is gradual, a seamless shift that mirrors the planet's calm demeanor. You let this transition guide you, your mind quieting, your breath steady. As darkness falls, the stars reappear, their light sharp and brilliant against the black void. Mercury's surface cools rapidly, contracting once again, the rocks settling into the stillness of night. The silence deepens, wrapping the planet in a blanket of calm. As the cycle continues, unbroken and eternal, you feel the timelessness of this rhythm, the balance of light and dark, of heat and cold. Mercury's journey around the sun is steady and deliberate, a reminder that even in the vastness of space, there is order and harmony. You let this thought carry you, the silence of Mercury becoming your own, the stillness of its surface becoming your stillness. The night returns fully now, spreading its cold, quiet embrace over Mercury's surface. The sun has disappeared below the horizon, leaving behind only the faintest glow of its memory, a subtle gradient of light fading into the darkness. The stars emerge one by one, their brightness uninterrupted by any atmosphere. The constellations seem sharper here, their ancient patterns clearer, as though the universe itself is leaning closer to whisper its secrets. The surface cools rapidly, the stored heat of the long day radiating away into the infinite void of space. The rocks, which had expanded under the sun's intense heat, now contract once again, their surfaces cracking and shifting imperceptibly. It is a quiet, almost imperceptible rhythm, a deep exhalation from the planet itself, settling into the stillness of night. As you drift above the planet, you notice the delicate interplay of shadow and light within its countless craters. Even in the absence of the sun, the reflected starlight reveals subtle details. The ridges of crater walls, the smooth plains at their centers, and the faint, dust-like patterns of debris scattered across the surface. Mercury's scars tell a story of its long life, of the collisions and forces that shaped it over billions of years. Moving further into the polar regions, the shadows grow deeper, more permanent. Here, in the perpetual darkness of craters untouched by sunlight, lies one of Mercury's most intriguing features: frozen water. The ice, shielded from the sun for eons, glimmers faintly under the distant starlight. These deposits, hidden in the planet's coldest, darkest recesses, are relics of the solar system's past, carried here by ancient comets or formed from Mercury's own materials. The contrast between the icy poles and the blazing heat of the equator is striking. Mercury is a planet of extremes, yet these contrasts coexist in perfect balance. It is a world that endures, adapting to the relentless pull of the sun and the harshness of its environment. This balance, this harmony of opposites, feels soothing, grounding, as though Mercury itself offers a quiet lesson in resilience. Looking to the horizon, you sense the faint curve of the planet against the backdrop of space. Mercury, small and dense, orbits so close to the sun that it completes its journey in just 88 Earth days. This rapid orbit is counterbalanced by its slow rotation, creating a unique rhythm where one day lasts twice as long as a year. It is a rhythm that is both deliberate and eternal, a dance that Mercury has performed since its creation. High above, the faint glow of Mercury's exosphere becomes visible again. Sodium, potassium, and other elements drift in a tenuous halo around the planet, illuminated by the distant starlight. These particles, released from the surface by solar wind and micrometeoroid impacts, create a fragile connection between Mercury and the vast expanse of space. It is as though the planet is reaching out, quietly interacting with the universe around it. The night deepens, and the temperature plummets even further. Mercury's surface is now colder than the frozen craters at its poles, the rocks contracting into stillness under the weight of the frigid darkness. And yet, this stillness is not emptiness. It is the quiet strength of a world that has endured for billions of years. The silence is profound, a calm that seems to echo through the void, enveloping you in its serenity. As you continue to drift, the horizon begins to change once more. A faint glow appears, a soft light that signals the sun's slow return. It is not yet visible, but its presence is felt, a promise of warmth and light that will soon spread across the surface again. The stars begin to fade, their brilliance dimming as the sun's light grows stronger. You watch as the glow intensifies, creeping across the rugged terrain and illuminating the tops of cliffs and craters. The sun rises slowly, painting the surface in shades of gold and amber. The rocks, frozen and still, begin to expand as the warmth touches them, cracks forming and deepening under the relentless heat. The cycle begins anew, the planet transitioning seamlessly from the stillness of night to the intensity of day. You let this transition guide your thoughts, your breath steady and calm. The rhythm of Mercury, unhurried and eternal, carries you. The silence, the balance of extremes, the timeless orbit, all of it lulls you into a deeper state of peace. You are part of this ancient cycle, a witness to the quiet beauty of a world that has endured the passage of time. The light grows stronger, the shadows retreat, and Mercury's surface awakens once more. The sun, now high above the horizon, dominates the sky, its light casting sharp, clear shadows across the rugged terrain. You feel the energy of this transition, the steady return of warmth and light, as the planet continues its endless journey around its star. The sun climbs higher into Mercury's sky, its unyielding brilliance illuminating every ridge, every crater, and every plain. The surface begins to shimmer with heat as the rocks and dust absorb the sun's energy, expanding and radiating warmth back into the airless void. The heat is so intense that the landscape appears to ripple, like waves of energy spreading silently across the planet. You glide over the towering cliffs once more, the scarps etched deeply into the planet's crust. These ancient formations, rising like frozen waves, tell the story of a planet that has cooled and contracted over eons. The ridges stretch endlessly, their jagged edges casting sharp shadows against the rocky plains. They are Mercury's fingerprints, unique and unchanging, each one a testament to the slow and steady transformation of this small, resilient world. Your path takes you toward the terminator, the line where day meets night. Here, the extremes of Mercury's environment are most evident. On one side, the sun blazes overhead, its searing heat dominating the landscape. On the other, the deep cold of space lingers, a quiet, frozen stillness. The transition between these two worlds is stark, and yet there is a harmony in the balance of light and shadow, of heat and cold. As you cross the terminator, the starkness of Mercury's day gives way to the softer hues of dusk. The sun lowers in the sky, its light stretching longer and more golden across the rugged terrain. The craters and valleys are bathed in a warm, amber glow, their details softened by the angle of the light. The planet seems to exhale, as though it, too, feels the relief of the approaching night. Drifting lower, you pass over a plain dotted with small, bright hollows. Their reflective surfaces catch the last rays of sunlight, glowing faintly like tiny beacons scattered across the darkening landscape. These hollows, mysterious and unique to Mercury, remain a puzzle even to those who have studied the planet. They shimmer with an otherworldly beauty, adding an unexpected softness to the otherwise rugged surface. Farther along, you encounter another vast plain, its surface smooth and dark, a remnant of ancient volcanic activity. These plains, once filled with molten lava, are now solid and still, their surfaces cracked and weathered by billions of years of exposure. The light fades slowly across them, the shadows stretching longer and longer, until they merge into the growing darkness of the approaching night. As the sun sinks below the horizon, the stars begin to return. One by one, they pierce the sky, their light sharp and steady in the absence of an atmosphere. The Milky Way emerges once more, its vast, glowing band of stars a reminder of the universe's enormity. You feel the quiet stillness of the night descending over Mercury, a deep calm that seems to echo through the silent void. The temperature plummets again, and the rocks begin to contract as the stored heat of the day radiates away. Cracks deepen, and the surface settles into the chill of night, its stillness undisturbed by winds or weather. Mercury's surface becomes a world of contrasts once more, the faint starlight illuminating the sharp lines of craters and ridges against the dark plains. Floating above the surface, you sense the planet's timeless rhythm. Mercury's orbit around the sun, its slow rotation, the unbroken cycle of day and night. All of it continues, steady and unchanging. The silence of the planet is profound, a stillness that stretches across the eons, offering a sense of peace and stability. You let yourself drift higher, gazing down at Mercury as a whole. From this perspective, the planet appears small but resilient, a dense, rocky world that has endured the extremes of the sun's energy and the chaos of the early solar system. Its surface, though scarred and rugged, reflects a quiet strength, a testament to the enduring balance of nature. The night deepens, and the stars shine brighter, their light illuminating the faint halo of Mercury's exosphere. This delicate atmosphere, composed of particles ejected from the surface, drifts gently around the planet, a subtle connection between Mercury and the universe beyond. It is as though the planet itself breathes, exhaling fragments of its story into the vastness of space. The silence grows deeper, wrapping the planet in its embrace. The cold of the night is absolute, and yet there is warmth in Mercury's enduring presence. The planet, though battered by time and the sun's relentless energy, continues its journey around its star, unyielding and steady. As the hours pass, the horizon begins to lighten once more. The faintest glow appears, a soft promise of the sun's return. The stars begin to fade, their brilliance overtaken by the growing light of dawn. The cycle begins anew, the unbroken rhythm of Mercury's existence continuing as it has for billions of years. You feel this rhythm within you, a steady pulse that mirrors the planet's quiet strength. The silence of Mercury becomes your own, the stillness of its surface grounding you in the infinite calm of the cosmos. The light grows stronger, the day begins, and the story of Mercury continues. The first glow of dawn spills over Mercury's horizon once more, soft and tentative at first, but growing steadily. The jagged edges of cliffs and crater rims catch the light before anything else, gleaming like golden crowns atop a rugged, shadowed landscape. The sun, though still hidden from view, begins to announce its arrival with a gradual spreading of warmth and illumination. The surface, so cold and still during the night, starts to awaken. The light reveals the planet's intricate details, each ridge and valley etched with precision over billions of years. Mercury's surface is not smooth but textured, a testament to the ceaseless forces that shaped it. The craters speak of ancient impacts, moments of violent creation that left their mark forever. The vast plains, meanwhile, tell of calmer times, when lava flowed freely, filling low-lying areas and creating seas of solidified rock. You float closer, feeling the sun's presence growing stronger. Its light, unfiltered by any atmosphere, strikes the surface directly, bathing everything in sharp, vivid clarity. Shadows retreat, shrinking into the depths of craters and the bases of cliffs as the sun climbs higher. The airlessness of Mercury means there are no soft gradients, no gentle fades between light and dark, only stark contrasts, defined by the sun's relentless energy. The surface begins to warm, and with it, a subtle transformation takes place. The rocks expand under the intense heat, their surfaces cracking and shifting as they adjust. The fine layer of dust that covers much of the planet glitters faintly, reflecting the sun's brilliance. This dust, or regolith, is the product of countless collisions, micrometeoroids striking the surface, breaking down rocks into smaller and smaller particles. Each grain is a fragment of history, a piece of Mercury's endless story. The sun rises fully now, dominating the sky with its overwhelming presence. Its light reveals the bright hollows scattered across the plains, their reflective surfaces shimmering like pools of liquid light. These mysterious features remain one of Mercury's greatest enigmas. Scientists theorize that they are the result of volatile materials sublimating under the sun's heat, but their precise nature is still unknown. They add an otherworldly beauty to the planet's rugged surface, a touch of softness amidst the starkness. Drifting higher, you take in the expanse of the Caloris Basin, one of the largest impact craters in the solar system. Its massive size, spanning over 1,500 kilometers, is a reminder of the immense forces that shaped Mercury's early years. The basin's floor is smooth, filled with solidified lava that flowed long after the initial impact. Surrounding it are concentric rings of mountains, their peaks sharp and imposing, like ripples frozen in stone. Beyond the basin, the scarps rise once more, their jagged ridges stretching for hundreds of kilometers. These cliffs, formed as the planet cooled and contracted, are among Mercury's most striking features. They stand as monuments to the passage of time, their sheer faces casting long shadows across the plains below. You can almost feel the forces that created them, the immense pressure of a shrinking world reshaping itself from within. The sun climbs higher still, and the heat intensifies. The surface becomes an inferno, the temperature soaring to levels unimaginable on Earth. Yet, even in this extreme environment, Mercury remains steadfast. Its dense core, the source of its weak but persistent magnetic field, anchors it firmly in its orbit. The magnetic field, though faint, offers a glimpse into the planet's dynamic past, when its core was more active and its surface more volatile. As the day progresses, the rhythm of Mercury becomes more apparent. The slow rotation means that the sun's journey across the sky is deliberate, almost meditative. A single day on Mercury lasts 176 Earth days, a stretch of time that feels infinite in its unhurried pace. You find yourself drawn into this rhythm, your thoughts slowing, your breathing matching the planet's deliberate cycle. The shadows lengthen as the sun begins its descent, the golden light softening and spreading across the landscape. The craters, ridges, and plains are bathed in the warm hues of late afternoon, their details once again becoming more pronounced as the angle of the light changes. The surface, though searingly hot, seems to settle, as though preparing itself for the approaching night. You drift toward the horizon, where the light begins to fade into darkness. The terminator, the line between day and night, approaches, its edge sharp and clear. Crossing it, you feel the sudden shift in temperature, the intense heat of the day giving way to the deep cold of night. The transition is stark, but also peaceful, a reminder of Mercury's delicate balance. As night falls, the stars return once more, their light sharp and unchanging. The silence deepens, the stillness of the planet enveloping you completely. The cycle begins again, unbroken and eternal, a rhythm that has persisted for billions of years. Mercury continues its quiet journey around the sun, resilient and enduring, a world defined by contrasts yet unified in its harmony. You let this rhythm carry you, your thoughts dissolving into the stillness of the night. The silence of Mercury becomes your own, the balance of light and dark, heat and cold, anchoring you in the vast expanse of the cosmos. You drift, weightless and calm, as the planet's story unfolds around you, timeless and infinite. The stars now blanket the sky, each point of light a distant sun, reminding you of the vastness that stretches far beyond Mercury's orbit. The Milky Way glimmers, a soft, luminous band that arcs across the heavens, connecting one end of the galaxy to the other. The darkness of space feels infinite, yet Mercury's presence beneath you grounds you, a small but resilient world bound to its star by invisible threads of gravity. The planet's surface, still radiating the heat of the day, begins to cool rapidly as the sun's warmth fades entirely. The rocks and regolith contract, their surfaces cracking softly in the absence of sound. It is a quiet transformation, almost imperceptible, as the searing heat of the day gives way to the deep cold of night. Mercury seems to exhale, sinking into the stillness of space, preparing for the long hours of darkness ahead. You float above the shadowed plains, their features softened by the dim light of distant stars. The larger craters, their walls high and imposing, cast shadows that stretch endlessly across the terrain. Inside these craters, the darkness is absolute, untouched by any light since their formation billions of years ago. The stillness here feels ancient, a kind of frozen eternity that has remained unchanged since the solar system's earliest days. The polar regions, perpetually locked in shadow, come into view again. These craters, forever hidden from the sun's rays, hold their secret, deposits of water ice, preserved for billions of years. The ice glints faintly, catching the faint starlight and reflecting it back as a subtle shimmer. These frozen patches are relics of the solar system's chaotic youth, when comets and asteroids brought water and other materials to planets like Mercury. Drifting lower, you sense the profound silence that envelopes the planet. There is no wind, no sound, no movement, only the quiet stillness of a world untouched by life. The silence feels vast, expansive, as though it stretches across the eons, carrying with it the weight of Mercury's ancient history. You let this silence surround you, allowing it to calm your thoughts and slow your breathing. As the night deepens, Mercury's exosphere becomes more pronounced. This delicate halo, composed of atoms ejected from the surface, drifts gently around the planet. Sodium and potassium glow faintly, energized by the sun's radiation even from beyond the horizon. The exosphere is a fragile and transient feature, constantly replenished and just as easily eroded. It is a subtle reminder of Mercury's ongoing connection to the sun, even in the depths of night. Looking upward, you see the stars begin to shift ever so slightly. Mercury's orbit carries it along its elliptical path, the planet constantly moving, though its motion feels imperceptible in the stillness of the moment. This slow, deliberate journey is part of Mercury's nature, its elliptical orbit bringing it closer to and farther from the sun in a rhythmic cycle that has continued for billions of years. Time seems to stretch here, each moment blending seamlessly into the next. A single night on Mercury lasts for weeks, yet it feels timeless, unhurried. The slow rotation of the planet creates a sense of stillness, a pause in the constant motion of the cosmos. You feel yourself sinking with this rhythm, your thoughts slowing, your mind becoming as quiet and steady as the planet below. As the hours pass, the horizon begins to glow faintly once again. It is the first hint of dawn, the soft light of the sun creeping upward from beyond the edge of the planet. The transition from night to day is slow, deliberate, like the opening of a curtain to reveal a stage. The stars begin to fade, their brilliance overtaken by the growing light of the sun. The craters and ridges of Mercury's surface start to emerge from the shadows, their edges sharp and clear in the early morning light. The sun's rays reach the highest peaks first, illuminating them with a golden glow that spreads slowly across the rugged terrain. The surface, though still frozen from the night, seems to come alive in the presence of the sun's warmth. You let yourself drift with the light, following its steady progress as it spreads across the planet. The shadows retreat, the warmth grows, and the cycle begins anew. Mercury's rhythm, so unchanging and eternal, carries you along, its quiet strength a source of calm and reassurance. The sun finally breaks fully over the horizon, its light flooding the landscape in sharp contrast. The planet's surface begins to heat once more, the rocks expanding and the hollows shimmering brightly. The day stretches out ahead, another chapter in Mercury's unending story, a reminder of the balance and harmony that governs even the most extreme of worlds. As the sun climbs higher in Mercury's sky, its rays spread across the surface with a growing intensity. The golden glow of dawn transitions into the piercing brilliance of full daylight. The landscape awakens under the sun's powerful light, and the sharp contrasts between shadow and illuminated rock grow even more pronounced. Mercury's surface, a patchwork of craters, plains, and ridges, becomes a vibrant tableau of textures and forms, each detail etched deeply into the planet's ancient crust. The searing heat begins to take hold, and the rocks expand once again under the relentless solar energy. The hollows scattered across the terrain shine brightly, reflecting the sunlight with an otherworldly radiance. These enigmatic features stand out starkly against the darker regolith, their origins still shrouded in mystery. They seem to shimmer with life, as though Mercury itself whispers of the secrets it has kept for billions of years. Your path takes you across the vast plains near the planet's equator, where ancient lava flows once smoothed the surface. These plains, dark and expansive, stretch outward like seas of stone, their surfaces fractured and weathered by time. Each crack and crevice is a mark left by the planet's slow cooling, the result of internal heat radiating away into space. The plains tell a quieter story than the craters or scarps, but they are no less important, a testament to the gradual forces that have shaped Mercury over eons. Drifting higher, you gaze down at Mercury's stark beauty. The bright sunlight reveals every ridge and valley in sharp detail, casting deep shadows that stretch across the surface. The Caloris Basin comes into view again, its immense size and circular symmetry dominating the surrounding terrain. This massive crater, formed by a cataclysmic impact long ago, is a reminder of the violent forces that shaped the early solar system. Its floor, filled with smooth volcanic plains, glows faintly under the sun's relentless glare. Moving beyond the basin, you come across the scarps once more, those towering cliffs that ripple across the landscape like frozen waves. These ridges, formed as the planet's core cooled and contracted, are some of the most striking features on Mercury. They rise sharply from the plains, their steep faces catching the sunlight and casting long, dramatic shadows. Each scarp is a monument to the planet's evolution, a silent witness to the slow but unstoppable changes that have defined Mercury's existence. The sun, now high in the sky, dominates everything. Its brilliance floods the surface, overpowering the stars and casting an intense, unyielding light. Mercury's lack of atmosphere means there is no filter, no softening of the sun's rays, only the raw, direct energy of a star shining at close range. The heat becomes almost unimaginable, yet the planet endures, as it has for billions of years. You find yourself drawn to the terminator once again, the boundary where day meets night. Here, the stark contrast between light and shadow is most evident. On one side, the sun's rays illuminate the landscape with searing intensity. On the other, the darkness of night holds fast, a world still frozen in the chill of space. The balance between these extremes is striking, a reminder of Mercury's duality, its existence defined by contrasts. As the sun begins its slow descent, the light softens, casting the surface in warm, golden hues. The craters and ridges, so harsh and sharp in full daylight, now appear more serene, their edges blurred by the angle of the light. The shadows grow longer, stretching across the plains and filling the valleys with darkness. The planet seems to exhale, the heat of the day gradually giving way to the calm of evening. The Terminator advances once more, bringing with it the approach of night. The temperature begins to drop, the intense heat radiating away into the vacuum of space. The rocks contract, their surfaces cracking faintly in the profound silence. Mercury's surface, so alive with energy during the day, returns to stillness, settling into the quiet of the approaching night. As the sun dips below the horizon, the stars reappear, their light sharp and unchanging against the black void. The Milky Way stretches across the sky, its soft glow a reminder of the galaxy's vastness. Mercury's surface fades into shadow, the features that were so vivid in the sunlight now dissolving into the depths of night. You hover above the planet, feeling the profound stillness of this transition. The silence deepens, the cold of night spreads, and the stars grow brighter, filling the sky with their steady light. The cycle has come full circle once more, the unbroken rhythm of Mercury continuing as it always has. Day turns to night, light to shadow, heat to cold. A balance as old as the planet itself. You let this rhythm carry you, your thoughts dissolving into the quiet. The stillness of Mercury becomes your stillness, its silence your silence. You drift, weightless and calm, as the planet continues its endless journey around the sun. A timeless dance of light and dark, of fire and ice, of endurance and grace. The stars now shine with their full brilliance, unobscured by any atmosphere, their light sharp and pure. The vastness of space stretches endlessly above, a dark canvas sprinkled with countless points of light. The silence of Mercury's night grows deeper, wrapping the planet in a stillness that feels almost eternal. The surface lies frozen under the absence of the sun, every grain of dust, every crack in the rock radiating the memory of the intense heat it bore just hours before. You float above the darkened plains, their features softened by the dim glow of starlight. The craters, so sharply defined in daylight, now seem quieter, their jagged edges blending into the surrounding terrain. The vast scarps and ridges, once striking in their sunlight-drenched prominence, are now gentle silhouettes, their outlines faint but enduring against the stark void of the horizon. Drifting lower, you approach the polar regions again where the shadows never retreat. These craters, forever cloaked in darkness, hold their frozen treasures, ancient water ice, untouched by time or the sun's heat. The ice glimmers faintly, reflecting the distant starlight like scattered fragments of crystal. These silent, hidden places are reminders of Mercury's extremes, where scorching heat and perpetual cold exist side by side, a balance that defines the planet's nature. The night deepens, and the cold intensifies. The rocks, which expanded under the sun's heat, now contract once more, their surfaces cracking with subtle shifts. These small, almost imperceptible movements are the echoes of Mercury's rhythm, the steady cycle of day and night that has played out for billions of years. The silence remains absolute, the airless environment carrying no sound, no movement, only the profound stillness of a world untouched by life. Above, Mercury's exosphere shimmers faintly, a fragile halo of particles drifting in the vacuum of space. Sodium and potassium atoms, energized by the sun's radiation during the day, now glow faintly under the stars. This exosphere is a delicate veil, constantly replenished by impacts and solar wind, yet it persists, a testament to the planet's quiet interaction with its surroundings. It is as if Mercury itself breathes softly, exhaling fragments of its story into the cosmos. You rise higher, taking in the planet's full curve, its surface illuminated faintly by the glow of the stars. Mercury appears small yet resilient, its scars and features a record of its ancient history. Its dense, iron core anchors it firmly in place, keeping the planet steady in its orbit around the sun. Despite its proximity to such an immense and powerful star, Mercury endures, its journey unbroken and unwavering. Time stretches here, the hours of Mercury's night blending seamlessly together. Each moment feels infinite, unhurried, as though the planet itself exists outside of time. The slow rotation, the long cycles of light and dark, create a rhythm that feels eternal. You find yourself syncing with this rhythm, your thoughts slowing, your breath steady and calm, as though you are a part of the planet's quiet, deliberate motion. As the hours pass, A faint glow begins to appear on the horizon once more. The first hints of dawn spread softly across the landscape, the light creeping upward in a gradual, deliberate unveiling. The stars begin to fade, their brilliance overtaken by the approaching sun. The shadows retreat slowly, their edges dissolving as the light touches the highest peaks of Mercury's craters and cliffs. The sun rises again, its rays spilling over the horizon and flooding the surface with warmth and light. The transition from night to day is seamless, a slow, graceful shift that mirrors the planet's calm and steady nature. The rocks expand under the sun's energy, the heat awakening the surface from its frozen stillness. The hollows, those enigmatic bright features, catch the light first, glinting like scattered jewels across the rugged plains. The cycle begins anew. Day turns to night and night back to day, a rhythm as old as Mercury itself. The planet continues its quiet journey around the sun, a path carved out over billions of years, a testament to the balance and endurance of the cosmos. You let yourself drift with this rhythm, carried by the planet's timeless motion. The silence of Mercury becomes your silence, the stillness of its surface grounding you in the infinite calm of space. The sun climbs higher, the light grows stronger, and the story of Mercury continues. A story of resilience, of balance, of quiet, enduring beauty. The sun climbs steadily in Mercury's sky, its light now touching every corner of the planet's rugged surface. The golden glow of early morning gives way to the stark brightness of full daylight, and the landscape sharpens once again under the unrelenting brilliance of the sun. The craters, cliffs, and plains come alive with detail, their textures vividly outlined by the sharp contrast of light and shadow. The hollows scattered across the plains shine brightly, their reflective surfaces glimmering like tiny pools of molten silver. These enigmatic features, so unique to Mercury, seem to hold the planet's secrets within their shimmering boundaries. As you drift over them, you feel their mystery, silent witnesses to a history that stretches back to the solar system's earliest days. What forces created these hollows? What story do they tell of Mercury's evolution? The answers seem just out of reach, adding to their quiet allure. The heat intensifies as the sun rises higher, and the rocks below begin to radiate warmth back into space. Mercury's surface, exposed directly to the sun's unfiltered energy, absorbs the light with a relentless efficiency. The temperature soars, the heat creating a shimmering haze over the rocky terrain. You watch as the planet endures this searing intensity, its rugged surface showing no signs of yielding to the extremes it has faced for billions of years. Your path takes you over the towering scarps once more, their jagged ridges cutting across the landscape like frozen waves. These immense cliffs are among Mercury's most striking features, rising sharply from the plains and stretching for hundreds of kilometers. They are scars left by the planet's slow cooling and contraction, a process that has shaped its surface over eons. The scarps stand as monuments to Mercury's resilience, silent reminders of the forces that have shaped it from within. Beyond the scarps, the Caloris Basin comes into view again. This massive impact crater, with its smooth, lava-filled floor and surrounding mountain rings, is a testament to Mercury's violent past. The energy released during its formation was so immense that it rippled through the planet, creating chaotic terrain on the opposite side. The basin's size and symmetry are breathtaking, a reminder of the cosmic forces that continue to shape the universe. You rise higher, taking in the full expanse of Mercury from above. The planet appears small but mighty, its surface a patchwork of craters, ridges, and plains that tell the story of its long and complex history. Mercury's dense iron core, hidden beneath its rocky shell, anchors the planet firmly in its orbit. This core generates a faint magnetic field, a quiet echo of the dynamic processes that once roared within. Time feels different here, stretched by the planet's slow rotation and long days. A single day on Mercury lasts longer than its year, creating a rhythm that feels both eternal and deliberate. The sun's path across the sky is slow and unhurried, its light moving steadily from horizon to horizon. You feel yourself syncing with this rhythm, your breathing slowing, your thoughts quieting, as though Mercury's pace has become your own. The sun begins its slow descent, and the light softens once again. The harsh brightness of midday gives way to the warm hues of evening, and the shadows grow longer, stretching across the plains like dark rivers. The craters and ridges, once starkly illuminated, now take on a softer appearance, their edges blurring in the golden light of late afternoon. As the horizon darkens, the terminator, the line between day and night, approaches. Crossing it, you feel the sudden transition from light to shadow, from heat to cold. The surface, which glowed with the sun's energy just moments before, now begins to cool rapidly, the warmth radiating away into the emptiness of space. The rocks contract once more, their surfaces settling into the stillness of night. The stars return, their light filling the darkened sky. Without an atmosphere to obscure them, they shine with an unmatched brilliance, their patterns vivid and eternal. The Milky Way stretches across the heavens, a river of light connecting Mercury to the galaxy beyond. The silence deepens, the stillness of night spreading across the planet like a blanket. You let yourself drift above this timeless world, feeling the quiet strength of Mercury's presence. Its scars, its extremes, its contrasts. All of it speaks to a planet that has endured, that has weathered the passage of time with a quiet grace. The cycle continues. Day turns to night, light to shadow, heat to cold. The rhythm of Mercury is unbroken, as steady and constant as the planet's orbit around the sun. You feel this rhythm within you, a steady pulse that mirrors the planet's quiet endurance. The silence of Mercury becomes your silence, its stillness your stillness. The stars above shine steadily, their light a reminder of the vastness of the universe, of the countless worlds that share this cosmic dance. And as Mercury continues its journey, so too do you drift, weightless and calm, carried by the timeless story of this ancient world. The stars overhead seem to grow brighter as the night deepens. Each one is a distant sun, its light traveling across unimaginable distances to reach Mercury's surface. The planet below lies in stillness, the darkness of night enveloping every ridge, crater, and plain. The silence feels eternal, as if Mercury itself is holding its breath under the vast expanse of the cosmos. You hover above the polar regions once again, where the sun's light never reaches. Here, in the craters that are locked in perpetual shadow, the ancient ice glistens faintly under the starlight. These frozen reserves, untouched for billions of years, seem out of place on such a searingly hot planet, yet they are a vital part of Mercury's story. This is a place where extremes coexist, where the blazing heat of the day contrasts with the eternal cold of these shadowed craters. The surface contracts further as the temperature plummets, the rocks settling into the deep freeze of night. Cracks form and deepen, creating tiny, imperceptible shifts across the surface. These subtle changes are echoes of the planet's rhythm, a cycle of expansion and contraction that has repeated countless times over its long history. It is a quiet, enduring process, a reflection of Mercury's ability to adapt and persist. Drifting higher, you observe Mercury as a whole. Its surface, now shrouded in darkness, is dotted with faint reflections of starlight on its most reflective features. The hollows, though harder to see in the dim light, still shimmer faintly, their brightness undiminished by the cold. These mysterious formations seem almost alive, as if they are windows into the planet's soul, offering a glimpse of its inner workings. The exosphere becomes more pronounced in the darkness. Sodium and potassium atoms, faintly glowing and drifting gently around the planet, form a fragile halo. This tenuous atmosphere, constantly replenished and eroded by the forces of space, is Mercury's quiet connection to its surroundings. It is a subtle reminder that even in silence, there is interaction, a continuous exchange between the planet and the cosmos. The hours stretch on, and the night feels infinite. Mercury's slow rotation means that darkness lingers, the planet taking its time to turn back toward the sun. This unhurried pace feels calming, as though Mercury itself is inviting you to slow down, to embrace the stillness and let the quiet rhythm of its cycle carry you. As the horizon begins to lighten once more, the first hints of dawn appear. A soft, golden glow spreads across the edge of the planet, signaling the sun's slow return. The stars fade gradually, their brilliance overtaken by the growing light. The transition from night to day is seamless, a gentle unveiling of the rugged surface that has rested quietly through the long hours of darkness. The sun rises slowly, its rays reaching out to touch the highest peaks first. The scarps and ridges, those immense cliffs that crisscross the planet, catch the light and glow with a golden warmth. The craters, too, begin to reveal themselves, their sharp edges casting long shadows that stretch across the plains. The light spreads steadily, illuminating the surface in a slow, deliberate rhythm. The warmth of the sun awakens the rocks, which begin to expand as they absorb the energy. The temperature rises steadily, and the contrast between light and shadow grows sharper. The surface, which lay frozen and still just hours before, now radiates with the intensity of the sun's light. Mercury seems to come alive under this energy, its features standing out with renewed clarity. The hollows catch the sunlight and glint like scattered mirrors, their reflective surfaces dazzling against the darker regolith. The plains, once smooth and shadowed, now reveal their fractured and weathered textures. Every feature of Mercury's surface tells a story, from the chaotic impacts that scarred it to the slow, steady cooling that shaped its cliffs and ridges. You drift higher, watching as the day unfolds. The sun climbs higher into the sky, flooding the planet with light and heat. The silence remains absolute, the airless void carrying no sound, no movement, only the steady, unchanging rhythm of Mercury's existence. The planet's scars and features are a testament to its resilience, a world that has endured the extremes of the sun's energy for billions of years. Time stretches once more, the hours blending together as the sun continues its slow journey across the sky. The craters, ridges, and plains remain constant, their details illuminated and sharpened by the relentless light. The rhythm of day and night continues, unbroken and eternal, a cycle that defines Mercury's nature. As the sun begins its descent, the light softens again, and the shadows lengthen. The heat of the day fades, and the surface begins to cool. The craters and cliffs, so vivid in the midday light, take on a gentler appearance, their sharp edges softened by the golden glow of the setting sun. The Terminator line approaches once more, the boundary between day and night moving steadily across the surface. The shadows deepen, the darkness spreads, and the stars reappear, their light piercing the blackness of space. The night returns, wrapping the planet in its quiet stillness, the cycle beginning anew. You let this rhythm guide you, your breath slowing to match the planet's deliberate pace. The silence of Mercury becomes your silence, the stillness of its surface grounding you in the vast expanse of the cosmos. You drift, weightless and calm, as Mercury continues its timeless journey around the sun, a quiet testament to the balance and endurance of the universe. The night has fully returned to Mercury, enveloping the planet in its profound stillness. The surface, which radiated the intense heat of the sun just hours before, is now frozen under the cold embrace of the cosmos. Every crater and ridge, every scar from eons past, fades into the deep shadow of the night. The silence is complete, the airless void allowing no sound to disturb the serenity of this ancient world. High above, the stars shine with unwavering clarity, each one a distant sun casting its light across the vastness of space. The Milky Way arcs across the sky, a celestial river of stars, gas, and dust that reminds you of the interconnectedness of everything in the universe. The brilliance of the stars feels eternal, their light unchanging even as time stretches infinitely forward. You drift along the Terminator line, that delicate boundary where the last light of day meets the oncoming darkness of night. The transition here is sharp but beautiful, a vivid contrast of gold and deep black that mirrors the planet's duality. On one side, the sun's final rays linger, casting long, dramatic shadows that accentuate every detail of the landscape. On the other, the shadows grow deeper, merging into the enveloping darkness. Moving farther into the night, you find yourself over Mercury's polar regions. These craters, locked in perpetual shadow, have never seen the light of the sun. They are frozen in time, their icy floors untouched for billions of years. The faint starlight reflects off the ancient ice, creating a soft, silvery glow that contrasts with the deep blackness of the surrounding rock. These craters feel timeless, holding within them secrets of the solar system's distant past. The airless silence becomes even more profound as you hover above these shadowed craters. The cold here is absolute, a stark reminder of Mercury's extremes. While the day side of the planet burns under the sun's unrelenting heat, these polar craters remain frozen, a testament to the planet's balance of opposites. It is a harmony of extremes, a delicate equilibrium that defines Mercury's character. Rising higher, you take in the entire curve of the planet. In the darkness, Mercury appears almost serene, its surface a patchwork of faintly visible craters and plains. The exosphere, Mercury's delicate halo of particles, glows faintly, its sodium and potassium atoms catching the faint light of the stars. This tenuous atmosphere, so fragile yet persistent, drifts gently around the planet, connecting it to the surrounding cosmos. The hours of night pass slowly, Mercury's deliberate rotation stretching time as it carries the planet unhurriedly toward the next dawn. The rhythm of Mercury's cycle is steady and unchanging, a cosmic heartbeat that has endured for billions of years. You find yourself aligning with this rhythm, your breathing slowing, your thoughts becoming quieter, as though the stillness of the planet is seeping into your own being. As the first hints of dawn begin to appear on the horizon, the stars start to fade once again. A faint glow spreads upward, soft and golden, announcing the sun's return. The darkness begins to retreat, the shadows shrinking as the light creeps across the rugged terrain. The craters and ridges emerge slowly from the night, their details growing clearer with every passing moment. The sun rises, its light spilling over the planet's surface in a steady, deliberate wave. The highest peaks and ridges catch the light first, glowing with a golden brilliance that spreads across the landscape. The plains, once hidden in shadow, now reveal their fractured and weathered surfaces, their textures illuminated in the sharp clarity of Mercury's airless environment. As the warmth of the sun touches the surface, the rocks begin to expand again, their contraction during the night reversing under the growing heat. The surface seems to awaken, its stillness giving way to the quiet energy of a new day. The hollows, those mysterious, reflective features, shine brightly under the sun's rays, their shimmering surfaces adding a touch of wonder to the otherwise rugged terrain. The rhythm of Mercury continues, unbroken and eternal. Day turns to night, and night back to day, the cycle repeating endlessly as the planet journeys around the sun. You feel this rhythm within you, a steady pulse that mirrors the planet's quiet endurance. The silence of Mercury becomes your own, its stillness grounding you in the vastness of the cosmos. You drift higher, watching as the sun climbs into Mercury's sky once more. The light grows stronger, the shadows retreat further, and the planet's surface comes alive with detail. Every crater, every ridge, every plain tells a story, a testament to the forces that have shaped this ancient world over billions of years. And as the cycle begins anew, you find yourself carried by Mercury's timeless rhythm, a part of its endless journey through the universe. The sun now dominates the sky, casting its powerful light across Mercury's surface. Every feature, from the jagged edges of ancient craters to the smooth expanses of volcanic plains, glows with an intensity unique to this small, resilient world. The hollows, scattered like bright, reflective gems, shimmer in the midday brilliance, their mysterious origins adding to the planet's allure. As the heat rises, the rocks expand once again, their surfaces cracking faintly under the strain of the sun's relentless energy. These changes are subtle, almost imperceptible, but they are part of Mercury's ongoing cycle, a delicate balance between heat and cold, contraction and expansion. The surface, scarred and weathered, bears witness to countless repetitions of this cycle, its resilience unbroken. You drift toward the vast Colorus Basin, its immense size and symmetry standing out even in the stark brightness of the day. This ancient impact crater, stretching over 1,500 kilometers, is a reminder of the chaotic past that Mercury once endured. The mountains encircling the basin rise like frozen waves, their peaks casting sharp shadows across the smooth, lava-filled floor below. The basin's expanse tells a story of destruction and renewal, of a moment in time that shaped the planet forever. Beyond the basin, the scarps rise like immense walls across the landscape. These towering cliffs, formed as Mercury's interior cooled and contracted, are among the planet's most striking features. Their steep faces catch the sun's rays, glowing with a golden light that contrasts with the deep shadows at their bases. These scarps are monuments to the forces that have shaped Mercury, standing tall and unyielding against the passage of time. High above, the faint exosphere shimmers in the sunlight. This delicate halo of particles, drifting gently around the planet, is a reminder of Mercury's connection to its environment. The sodium and potassium atoms glow faintly, energized by the solar wind and the sun's intense radiation. Though fragile and constantly replenished, the exosphere is a quiet testament to Mercury's ability to endure and interact with the forces around it. The hours of daylight stretch on, the sun's journey across the sky slow and deliberate. Mercury's rotation, so much slower than its orbit, creates a rhythm that feels eternal. A single day here lasts longer than a year, and the unhurried pace of the sun's movement mirrors the planet's calm and steady nature. You feel yourself aligning with this rhythm, your thoughts slowing, your breath steady and deep, as if Mercury's tranquility has become your own. As the sun begins its descent, the light softens, bathing the surface in warm, golden hues. The craters and ridges, so stark and sharp in the midday light, take on a gentler appearance, their details softened by the angle of the setting sun. The shadows grow longer, stretching across the plains and filling the valleys, creating a dynamic interplay of light and dark. You approach the terminator once more, the boundary between day and night. The transition here is stark yet beautiful, the retreating light giving way to the encroaching darkness. The temperature begins to drop as the sun sinks below the horizon, and the surface, still warm from the day's heat, starts to radiate its energy back into space. The rocks cool and contract, their surfaces settling into the stillness of the approaching night. The stars reappear, their light sharp and unwavering against the black canvas of space. The Milky Way stretches across the sky once more, a luminous river that seems to connect Mercury to the farthest reaches of the cosmos. The silence deepens as the shadows merge, and the planet's surface fades into the darkness of night. You rise higher, gazing down at Mercury as the cycle begins anew. The planet, small yet enduring, continues its journey around the sun, its rhythm steady and unbroken. The contrasts of its existence, light and shadow, heat and cold, day and night, are part of what defines it, a balance that has persisted for billions of years. The night spreads across the surface, bringing with it the profound stillness that only Mercury can offer. The stars grow brighter, their patterns timeless and infinite. You feel the planet's quiet strength, its ability to endure extremes and find balance in the face of challenges. This stillness, this silence, becomes your own, grounding you in the vastness of the universe. Floating above Mercury, you sense the continuity of its story. Day turns to night, night back to day, an unchanging cycle that mirrors the timeless nature of the cosmos itself. You drift, weightless and calm, as the planet's rhythm carries you forward. The silence of Mercury wraps around you, the stillness of its surface anchoring you in the endless expanse of space. As Mercury's night deepens, the planet settles into a profound stillness. The shadows, long and soft at dusk, now merge completely, casting the surface into the full embrace of darkness. The craters and ridges fade into obscurity, their outlines barely visible under the faint light of distant stars. The temperature continues its rapid descent, plunging the rocks into a cold so deep it feels as though even time itself could freeze. Above, the stars shine with unparalleled clarity, their steady light cutting through the infinite darkness of space. The constellations seem to glow with a sharper brilliance, their patterns ancient and unchanging. The Milky Way once again dominates the sky, its arc a breathtaking reminder of the universe's vastness and the interconnectedness of all celestial bodies. Here, above Mercury's frozen surface, the stars feel closer, more immediate, as though the galaxy is wrapping itself around the small, resilient planet. You float above the polar craters, where the shadows are eternal and the silence even deeper. These regions, locked away from the sun's reach for billions of years, hold their icy secrets within their depths. The frozen water here, untouched by heat, glimmers faintly under the starlight. It is a fragile reminder of the past, of comets and asteroids that brought water to Mercury during the chaotic early days of the solar system. The icy floors of these craters feel timeless, their presence a quiet defiance of the sun's overwhelming energy. They exist in perfect harmony with the rest of the planet, balancing the searing heat of the day with the untouched cold of these shadowed enclaves. Mercury is a world of opposites, yet its extremes coexist beautifully, forming a delicate and enduring equilibrium. Drifting higher, you take in the entire night side of Mercury. The faint glow of the exosphere becomes more visible in the darkness, a halo of particles gently drifting above the surface. This fragile atmosphere, made of sodium, potassium, and other elements, glimmers softly, interacting with the faint solar winds that still reach Mercury even during the night. It is a quiet, almost imperceptible connection between the planet and the sun, a reminder that their bond remains unbroken even in the absence of light. Time slows as the hours of night stretch on. Mercury's rotation is so deliberate, so measured, that the passage of time feels almost irrelevant. Each moment blends seamlessly into the next, the steady rhythm of the planet's cycles creating a sense of calm and permanence. You feel this rhythm within you, your breathing matching the planet's slow, unchanging pace. The stillness becomes your own, the silence of Mercury enveloping you completely. As the horizon begins to lighten once more, the first whispers of dawn appear. The stars start to fade, their light gradually overtaken by the faint glow of the approaching sun. The transition from night to day is slow, deliberate, and serene, a gentle unveiling of the planet's surface. The craters and ridges, hidden in darkness for hours, begin to emerge as the light touches their edges. The sun rises with a quiet power, its rays spreading across the landscape like a golden tide. The highest peaks catch the light first, glowing with a soft brilliance that grows steadily brighter. The plains, which lay frozen and silent during the night, now come alive under the sun's warmth, their fractured surfaces shimmering as they begin to expand. The rocks awaken once more, their contraction during the cold of night reversing as the temperature climbs. The cycle begins anew, the unbroken rhythm of Mercury continuing as it has for billions of years. Day turns to night and night back to day, a balance as old as the planet itself. You feel this balance within you, a steady pulse that mirrors the planet's quiet endurance. The sun climbs higher, the light strengthens, and Mercury's surface is bathed once again in the sharp brilliance of the day. Floating above the planet, you see the details of its surface sharpen under the sun's light. The craters, ridges, and plains become vivid and clear, each one a marker of the forces that have shaped Mercury's history. The hollows, with their bright, reflective surfaces, catch the light and glimmer like scattered jewels across the rocky expanse. The scarps rise like immense walls, their jagged edges casting dramatic shadows that stretch across the terrain. The rhythm of Mercury's day is steady and deliberate, its pace unhurried. The sun's journey across the sky is slow, taking weeks to complete. You let yourself drift with this rhythm, your thoughts slowing, your breath calm and deep. The silence of Mercury becomes your silence, the stillness of its cycles grounding you in the vast expanse of the cosmos. As the sun continues its ascent, the heat intensifies, and the surface glows with a searing brilliance. The rocks expand further, their surfaces cracking faintly under the strain of the sun's energy. Yet even in this intensity, Mercury remains steadfast, enduring the extremes of its environment with quiet strength. The planet's resilience is a testament to its nature, a world that has weathered the chaos of the early solar system and found its balance in the face of extremes. The journey continues, the sun climbing higher into the sky, the cycle moving forward. Day turns to night, and night to day, the story of Mercury unfolding in its endless rhythm. You feel yourself carried by this rhythm, weightless and calm, a part of the planet's timeless journey through the universe. As the sun's rays continue to spread across Mercury's surface, the timeless rhythm of this ancient world carries on. Day transitions into night, light into shadow, and the planet, resilient and steadfast, completes another rotation in its slow, deliberate journey around the sun. You rise higher, watching Mercury fade into the vastness of space. Its rugged surface, marked by eons of impact and change, glimmers faintly in the distance, a small but enduring presence in the infinite cosmos. The silence that surrounds the planet is profound, a silence that stretches across time and space, offering a sense of peace that fills you completely. The stars, now faint against the brilliance of the sun, linger quietly in the background, a reminder of the vast, interconnected universe. Mercury, though close to its star, feels tied to these distant lights, part of the same intricate web of gravity and energy that holds the cosmos together. Let the balance of Mercury guide you, a world of extremes, yet harmonious in its contrast. Light and dark, heat and cold, day and night, all coexisting in perfect rhythm. Feel the planet's timeless journey echo within you, steady and calm, grounding you in the vastness of existence. As you drift farther away, Mercury becomes a tiny, glimmering dot in the blackness of space. Its story, etched into its surface, continues quietly, a testament to endurance and balance. And as you let go, the quiet rhythm of the planet stays with you, carrying you into a deeper peace, into the stillness of the universe itself. Rest now, as Mercury continues its silent orbit. The stars remain, the sun shines on, and the planet's journey endures, just as you find your own calm within the infinite rhythm of the cosmos. The birth of Venus. In the beginning, the solar system was a swirling maelstrom of gas and dust. Nebulous clouds spiraled in the gravitational embrace of the young sun, their chaotic collisions forming the seeds of what would one day become the planets. Among the fledgling worlds, one planet began to take shape, destined to be both a beacon of beauty and a monument to destruction: Venus. In its infancy, Venus was an inferno. Rivers of molten rock surged across its surface, glowing in hues of fiery red and orange. The young planet was bombarded by a relentless barrage of asteroids and comets, their impacts forging mountains, craters, and deep fissures. Around the molten surface swirled a dense, chaotic atmosphere, heavy with carbon dioxide and volatile gases, shrouding Venus in perpetual twilight. As millions of years passed, Venus began to cool. Its surface solidified into a crust of basaltic plains, dotted with towering volcanoes that belched noxious fumes into the already thick atmosphere. But the cooling process was far from a reprieve. Trapped beneath its oppressive gaseous cloak, the planet's heat could not escape. What might have been a haven for life was instead transformed into a hellish realm. Over eons, Venus's transformation became a testament to the power of cosmic forces. Its atmosphere thickened, growing denser with each volcanic eruption. Water vapor, perhaps carried by ancient comets, rose into the skies, forming clouds that would never yield rain. The sun's relentless heat triggered a runaway greenhouse effect. Hydrogen from water molecules escaped into space, leaving behind an increasingly arid, desolate world. Despite its harsh conditions, Venus thrived as a planet of extremes. Its atmosphere, now a crushing blanket of carbon dioxide, held temperatures hot enough to melt lead. Winds roared at hurricane speeds in the upper atmosphere, dragging sulfuric acid clouds around the planet in a perpetual storm. Yet, deep below, volcanic activity persisted, reshaping the surface with rivers of molten rock and vast lava plains. The surface of Venus bore the scars of its violent past. Shield volcanoes rose like sentinels, some stretching thousands of meters into the poisonous skies. Massive plateaus, born of tectonic upheaval, cracked under the relentless pressure of the planet's interior. Entire regions collapsed into labyrinthine depressions, while others erupted in catastrophic outflows of magma. Unlike Earth, with its shifting tectonic plates, Venus's crust acted as a single rigid shell. Heat trapped beneath it would periodically build to a breaking point, triggering cataclysmic resurfacing events that erased eons of geological history. There was a time, billions of years ago, when Venus might have been Earth's twin in more than size and composition. Early in its history, it may have hosted vast oceans, cradling the potential for life. But the sun's steady brightening doomed Venus. Its proximity to the star meant it absorbed more solar radiation than it could shed. Oceans boiled away, and the delicate balance that could have sustained life tipped irreversibly. As Venus's transformation into a fiery wasteland continued, it became a cautionary tale etched into the cosmos. Where Earth nurtured life, Venus suffocated under the weight of its atmosphere. Its surface, hidden from view by its thick clouds, became a mystery, a landscape seen only through radar mapping and fleeting glimpses from passing spacecraft. For centuries, Venus was the morning star and the evening star, a bright and constant presence in human skies. Ancient civilizations revered it, attributing divine qualities to its unyielding brilliance. But for scientists, Venus became a target of fascination and frustration. Early telescopic observations revealed little about its surface, obscured as it was by the planet's perpetual cloud cover. In the mid-20th century, humanity's curiosity turned into action. Spacecraft like the Soviet Venera series pierced the planet's dense atmosphere, enduring crushing pressures and extreme temperatures to send back the first tantalizing glimpses of its surface. They revealed a hellish world, volcanic plains, fractured terrain, and temperatures hotter than any human-engineered probe could withstand for long. Despite the danger, Venus became a gateway to understanding planetary evolution. Beyond its scientific significance, Venus carried symbolic meaning. To some, it was a vision of beauty, shining brightly in the sky as a beacon of hope and wonder. To others, it was a warning of the fragility of balance, a reminder of what might await Earth if the forces of nature were pushed too far. Venus, the second planet from the Sun, stood as a paradox. It was a planet of breathtaking beauty, yet utterly inhospitable. It shared a cosmic kinship with Earth, yet followed a path of destruction and desolation. It remained an enigma, forever beckoning humanity to uncover its secrets, to learn from its history, and to marvel at its raw power. As the millennia stretched into millions of years, Venus became a world entirely its own, alien and inhospitable. The sun's rays, more intense than those reaching Earth, baked the planet, while its dense atmosphere locked the heat in a deadly feedback loop. On the surface, temperatures climbed to a staggering 475 degrees Celsius, 887 degrees Fahrenheit, hot enough to liquefy lead. Pressures reached 92 times that of Earth's sea level, equivalent to being submerged under nearly a kilometer of ocean. The skies, though often imagined as serene and golden, were anything but. Venus's clouds churned with sulfuric acid, corrosive enough to destroy metals and strip any hypothetical life forms of their ability to survive. Lightning storms, immense and ceaseless, raged across the atmosphere, their electric tendrils flickering in the thick yellow haze. Winds at the cloud tops screamed at speeds exceeding 300 kilometers per hour, encircling the planet in a mere 4 days, an effect of the phenomenon known as superrotation. On the surface, there was no respite. The volcanic plains stretched endlessly, broken only by immense mountains and craters. One of these volcanic giants, Mont Mons, towered above the hellish landscape, a reminder of the planet's violent past. Lava channels carved paths hundreds of kilometers long, their ancient flows now solidified into black, glassy scars. Vast regions, such as the Tesserae, resembled the wrinkled skin of a crumbling giant, with intersecting ridges and fractures that hinted at the immense tectonic forces of Venus's interior. To imagine Venus billions of years ago is to see a planet not so different from Earth. Scientists hypothesize that ancient Venus may have had vast oceans, gentle breezes, and temperate climates. It was a world where water flowed freely, shaping valleys and canyons as it carved its path to primordial seas. Perhaps, under its once clear skies, primitive forms of life began to take root, feeding on the nutrients of a thriving young planet. But Venus's proximity to the sun set it on a different course. As the sun aged and grew brighter, the delicate balance was destroyed. The oceans, heated by relentless solar radiation, began to evaporate. Water vapor, a potent greenhouse gas, added to the growing atmospheric pressure. Trapped in this vicious cycle, Venus's surface grew hotter, accelerating the evaporation process until no liquid water remained. Without oceans to absorb carbon dioxide, the gas accumulated in the atmosphere, creating the thick, oppressive layer we see today. The planet that might have been Earth's twin became its stark opposite. A world where life could not survive, where even the simplest organisms would be crushed, burned, and dissolved in seconds. In humanity's quest to understand Venus, the Soviet Union led the charge. The Venera program, a series of spacecraft launched between the 1960s and 1980s, represented some of the most daring efforts in planetary exploration. Venera 7 became the first spacecraft to successfully land on Venus and transmit data back to Earth, though it lasted only 23 minutes before succumbing to the planet's extreme conditions. Later missions, like Venera 13 and 14, provided stunning insights, capturing the first images of Venus's surface and analyzing its soil composition. The images revealed a world unlike anything imagined. The ground was littered with jagged rocks, fractured by immense heat and pressure. The skies glowed a dim, sulfurous orange, creating an otherworldly ambience that seemed almost alive. Every discovery painted a clearer picture of Venus's brutality and its haunting beauty. The story of Venus is not just one of destruction, it is also a story of warning. On Earth, the greenhouse effect sustains life, keeping the planet warm enough for oceans, forests, and diverse ecosystems. But on Venus, this same process spiraled out of control, turning the planet into an inferno. As humanity grapples with its own challenges, rising temperatures, melting ice caps, and shifting climates, Venus serves as a grim reminder of what can happen when balance is lost. Its runaway greenhouse effect is a mirror, reflecting what Earth could become if natural systems are pushed beyond their limits. Despite its harsh conditions, Venus remains a tantalizing target for exploration. Future missions, such as NASA's Veritas and Europe's Envision, aim to unravel its mysteries further. Advanced radar systems will map its surface in unprecedented detail, searching for evidence of active volcanoes and ancient water flows. High-altitude balloons, floating above the worst of the atmospheric chaos, could provide long-term observations and even pave the way for eventual human exploration. Some scientists speculate about the possibility of terraforming Venus, a distant dream that would involve reducing its atmospheric pressure, cooling its surface, and introducing water. While such a feat is far beyond current technology, it sparks the imagination and highlights humanity's enduring desire to reshape the cosmos. Venus remains a paradox. To the naked eye, it is the brightest object in the night sky, a celestial jewel shining with unmatched brilliance. But beneath its luminous exterior lies a world of unimaginable extremes. It is both a vision of beauty and a warning of fragility, a reminder that even the most promising worlds can be consumed by the forces of nature. As humanity gazes up at Venus, the planet continues its silent journey around the sun. Its story, etched into its molten plains and turbulent skies, is one of both triumph and tragedy, a testament to the forces that shape worlds and the mysteries that still await discovery. Though Venus's surface is a death trap, its upper atmosphere holds surprising promise. At an altitude of 50 to 60 kilometers, the temperature and pressure closely resemble those of Earth's lower atmosphere. Here, amidst the swirling clouds of sulfuric acid, scientists envision a future where floating colonies, cloud cities, could thrive. These cities would hover like balloons, supported by the dense atmosphere, and be protected by advanced materials resistant to corrosion. Solar power would provide abundant energy, harnessing the intense sunlight that penetrates the upper atmosphere. Within these habitats, humanity could study Venus up close, learning from its history while preparing for the long-term goal of interplanetary habitation. For now, such visions remain in the realm of science fiction, but they highlight humanity's resilience and determination to turn even the most hostile environments into opportunities for discovery. Even in its unrelenting hostility, Venus sparks questions about the possibility of life. In 2020, scientists detected phosphine in Venus's upper atmosphere, a chemical that, on Earth, is often associated with microbial life. This discovery ignited debates and renewed interest in the planet as a potential host for extremophiles, organisms capable of surviving in extreme environments. Could life exist in Venus's acidic clouds? If so, it would be vastly different from anything on Earth. These hypothetical microbes would need to endure temperatures of up to 60 degrees Celsius, 140 degrees Fahrenheit, and thrive in an environment composed mostly of sulfuric acid. The search for life on Venus challenges our understanding of biology and forces us to reconsider what it means for a planet to be habitable. Unlike Earth, where plate tectonics constantly reshape the land, Venus's surface is static, locked in place by the immense pressure of its atmosphere. This lack of tectonic activity leads to periodic resurfacing events, where heat trapped beneath the crust bursts through in massive volcanic eruptions, flooding the surface with fresh lava. These events erase geological features and leave the planet's face perpetually young, geologically speaking. Radar imaging has revealed fascinating formations across Venus's surface. Pancake domes, immense and circular, rise like ancient ruins. Lava flows stretch for thousands of kilometers, carving canyons and valleys into the barren plains. Impact craters, scattered yet sparse, suggest that Venus's surface is relatively new, its age estimated to be only 300 to 500 million years, a blink of an eye in planetary terms. Though its surface is dry, Venus can be thought of as having an ocean of sorts, an ocean of clouds. These clouds, thick and reflective, give Venus its dazzling brightness when viewed from Earth. They are composed primarily of sulfuric acid, with traces of water vapor and other chemicals. This noxious ocean envelopes the planet, trapping heat and creating the infernal conditions below. Despite their toxicity, these clouds hold clues to Venus's distant past. Traces of deuterium, a heavy isotope of hydrogen, suggest that Venus once had vast quantities of water. This isotope, more abundant in Venus's atmosphere than on Earth, indicates that much of Venus's water was lost to space over billions of years, a silent evaporation of a planet's potential. For as long as humans have looked to the skies, Venus has captivated their imaginations. The ancient Greeks and Romans named it after their goddess of love and beauty, awestruck by its radiance. In Aztec mythology, Venus was known as Tlahuizcalpantecutli, the Lord of the Dawn. To the Maya, it was Chuk-Ek, the great star whose movements governed their calendar and rituals. Even today, Venus remains a symbol of duality. Its brilliance contrasts sharply with its reality, a world of fire and acid, where nothing soft or gentle can endure. Yet its story resonates with humanity's own journey, a tale of beauty, resilience, and the delicate balance between life and destruction. As Earth's closest planetary neighbor, Venus remains one of humanity's most compelling frontiers. Upcoming missions like NASA's Veritas, Venus Emissivity, Radio Science, NSAR, Topography and Spectroscopy, and Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, promise to shed light on Venus's complex history. Veritas will map the surface with unparalleled precision, revealing its geological secrets, while Da Vinci Plus will plunge through the atmosphere, sampling gases and capturing high-resolution images of the rugged terrain. Meanwhile, private organizations and international space agencies are developing ambitious concepts for long-term exploration. High-altitude airships, capable of navigating the dense clouds, could serve as mobile laboratories, while robotic landers, designed to withstand the surface conditions, could conduct extended studies. Each step brings humanity closer to understanding Venus, not just as a scientific curiosity, but as a vital piece of the puzzle in the story of our solar system. Venus's story is one of transformation, both cosmic and symbolic. It began as a molten sphere, a world forged in the fires of creation. It evolved into a planet that might have nurtured life, only to be consumed by its own atmosphere. Today, it stands as a beacon, a reminder of nature's power and the fragility of planetary systems. As we gaze upon Venus from Earth, its light inspires awe and reflection. It is a reminder of what was lost and what might still be found. Venus, the eternal morning star, continues to illuminate the mysteries of our universe, drawing us closer to the answers we seek and to the questions that remain. One of Venus's most intriguing phenomena is its super-rotating atmosphere. While the planet itself spins slowly, taking 243 Earth days to complete one rotation, its upper atmosphere races around the planet in just 4 Earth days. This creates winds that howl at speeds exceeding 300 kilometers per hour, whipping the sulfuric acid clouds into a perpetual tempest. Scientists have long sought to understand the forces driving this extreme atmospheric behavior. Theories suggest that solar heating, combined with Venus's dense atmosphere and slow rotation, creates powerful waves of energy that accelerate the winds. These waves, both planetary and atmospheric, act as unseen engines, propelling the clouds in an endless orbit around the planet. For future explorers, these winds could be both a challenge and an opportunity. High-altitude probes or balloons could ride the currents, collecting data while circling the planet in a matter of days. Understanding these winds could also provide insights into atmospheric dynamics on other worlds, including Earth. Beneath its thick shroud, Venus remains geologically active. Evidence of ongoing volcanism comes from both radar observations and infrared emissions detected from orbit. These data suggest that Venus's volcanoes are not relics of the past but active players in shaping the planet's surface and atmosphere. Volcanic activity may explain the high levels of sulfur dioxide in the upper atmosphere. Periodic eruptions release plumes of gas, injecting sulfur compounds into the clouds. Over time, these compounds react with sunlight, creating the dense, reflective layer that makes Venus so brilliant from Earth. The planet's volcanic features are as diverse as they are dramatic. Shield volcanoes like Sif Mons and Gula Mons rise as solitary giants, their broad slopes formed by countless lava flows. Vast lava plains stretch for thousands of kilometers, punctuated by caldera-like depressions that mark the collapse of ancient magma chambers. Unique to Venus are coronae, circular patterns of fractures and ridges caused by upwellings of molten rock beneath the surface. These structures, some hundreds of kilometers across, are a testament to the immense forces shaping Venus from within. Venus's history as a possible water world raises profound questions. What caused its oceans to disappear, and could they have harbored life? Modern theories suggest that Venus's fate was sealed by a combination of its proximity to the Sun and the runaway greenhouse effect. Early in its history, Venus might have been cooler with a thick atmosphere of water vapor. Over time, the increasing intensity of sunlight caused the water to evaporate, filling the atmosphere with even more water vapor. This amplified the greenhouse effect, raising surface temperatures until the oceans boiled away. As the water vapor rose to the upper atmosphere, ultraviolet radiation from the sun broke apart the water molecules into hydrogen and oxygen. The lightweight hydrogen escaped into space, while the oxygen likely reacted with surface minerals, leaving Venus dry and barren. The loss of Venus's water is a stark reminder of how fragile planetary conditions can be. It raises questions about the fates of other planets and exoplanets that orbit their stars in the so-called habitable zone. As humanity sets its sights on the stars, Venus remains a tantalizing goal. While Mars has captured much of the public's imagination as a potential home for human colonies, Venus offers its own unique challenges and opportunities. Its harsh conditions make surface exploration difficult, but its upper atmosphere, where temperatures and pressures are Earth-like, could one day host floating research stations or even colonies. NASA and other space agencies have proposed concepts for missions to explore Venus's atmosphere. These include airships equipped with solar panels to power long-term studies of the planet's climate and geology. Such missions could pave the way for a new era of exploration, where humans live and work above the clouds of Venus, harnessing its resources and unlocking its secrets. For now, robotic missions will lead the way. Advances in materials science could enable landers to survive on the surface for days or even weeks, transmitting high-resolution images and data about the planet's composition. These missions would be stepping stones to more ambitious projects, ensuring that Venus remains a central focus of planetary science. The story of Venus resonates deeply with the challenges facing Earth. Its transformation from a potential water world to a searing wasteland highlights the delicate balance required to sustain life. For scientists studying climate change, Venus offers a stark example of what can happen when a planet's natural systems spiral out of control. The lessons of Venus extend beyond science. They remind us of the interconnectedness of all things, how the fate of a planet depends on the interplay of forces both great and small. Venus is not just a warning. It is an invitation to reflect on our place in the cosmos and the responsibility we have to preserve the fragile equilibrium of our home planet. As the brightest object in the night sky after the moon, Venus continues to captivate humanity. Its light has guided travelers, inspired poets, and sparked the imagination of countless cultures. Yet, its true nature remains elusive, a world hidden behind its veils of sulfur and acid. For astronomers and dreamers alike, Venus is a reminder of the unknown. Its surface, mapped but rarely seen, holds secrets that could change our understanding of planetary evolution. Its atmosphere, thick and turbulent, challenges our notions of habitability and life. And its history, from potential ocean world to scorched inferno, speaks to the profound forces that shape planets and their destinies. Venus's journey through space is one of eternal contrast. It is a planet of light and darkness, beauty and destruction, possibility and loss. It reminds us that the cosmos is vast and varied, filled with worlds that defy our expectations and challenge our understanding. As humanity continues to explore Venus, we are not just uncovering the story of a distant world. We are also learning more about ourselves. Venus holds a mirror to our ambitions, our fears, and our relentless curiosity. It is a testament to the enduring power of exploration and the infinite possibilities of the universe. The atmosphere of Venus is a dynamic, multi-layered system, each level with its own unique characteristics and mysteries. At the highest altitudes, the planet is cloaked in thick clouds of sulfuric acid. These clouds reflect sunlight, giving Venus its dazzling brightness as seen from Earth, but also hiding its surface from direct observation. Beneath the clouds, the atmosphere becomes increasingly hostile. Carbon dioxide dominates, making up more than 96% of the gaseous composition. Traces of nitrogen, sulfur compounds, and other elements complete the deadly mix. Temperatures rise inexorably as one descends, reaching their peak at the surface, where the crushing pressure and searing heat combine to create conditions unlike any found elsewhere in the solar system. This stratified atmosphere is not static. Complex chemical reactions occur within it, driven by solar radiation and the extreme conditions below. Lightning storms crackle through the clouds, generating electromagnetic energy that might play a role in maintaining Venus's super-rotating winds. The balance of these processes has maintained the planet's atmospheric stability for billions of years, despite its surface being almost entirely resurfaced by volcanic activity. While the surface of Venus is a fiery wasteland, its interior remains even more enigmatic. Scientists theorize that Venus, like Earth, has a core of molten iron and nickel surrounded by a silicate mantle. However, The planet's lack of a significant magnetic field suggests that its core may not be active in the same way as Earth's. Without a protective magnetic field, Venus's atmosphere is exposed to the solar wind, which strips away lighter elements like hydrogen. This process has likely contributed to the loss of water over billions of years, further solidifying its place as an arid, lifeless world. Studying Venus's interior presents significant challenges. Unlike Earth, where seismic data provide insights into the planet's structure, Venus's extreme surface conditions make deploying sensitive instruments nearly impossible. Future missions may rely on innovative technologies, such as orbiting radar systems capable of detecting subtle gravitational variations, to probe the depths of this enigmatic planet. Evidence of past water on Venus tantalizes scientists. The planet's surface features suggest that, billions of years ago, it may have been shaped by flowing water. Ancient riverbeds and basins, visible through radar imaging, hint at a time when Venus's climate was far more hospitable. To uncover the truth, researchers study Venus's atmosphere for isotopic clues. The ratio of deuterium to hydrogen is significantly higher on Venus than on Earth, indicating that vast quantities of water were once present but have since been lost to space. This loss likely occurred over hundreds of millions of years, as rising temperatures caused the oceans to evaporate and solar radiation stripped the hydrogen away. Understanding the history of water on Venus could have profound implications for astrobiology. If Venus once had stable, liquid oceans, it may have supported microbial life. Discovering traces of ancient water would open new avenues of research into the conditions required for life to develop and thrive on other planets. Life as we know it depends on three key ingredients: liquid water, an energy source, and a stable environment. While Venus lacks these conditions today, its ancient history might tell a different story. For hundreds of millions of years, the planet could have been a temperate, ocean-covered world teeming with organic molecules. Recent discoveries have reignited the debate about Venus's potential for life. In 2020, researchers announced the detection of phosphine gas in Venus's upper atmosphere. On Earth, phosphine is associated with biological processes, though it can also be produced through abiotic means. This finding remains controversial, but it has spurred renewed interest in the possibility that microbial life could exist in the relatively mild upper atmosphere of Venus, where temperatures and pressures are similar to those on Earth's surface. Future missions aim to settle this debate. Atmospheric probes equipped with advanced instruments will sample the clouds for traces of organic compounds, searching for the chemical fingerprints of life. If even the smallest hint of life is discovered, it would transform our understanding of the universe and Venus's place within it. Despite their dramatic differences, Venus and Earth share striking similarities. Both are rocky planets of similar size, composition, and density, orbiting within the Sun's habitable zone. Yet their evolutionary paths diverged in ways that make Venus a cautionary tale for Earth. Venus's fate underscores the fragility of planetary environments. While Earth's climate has remained relatively stable, Venus's runaway greenhouse effect transformed it into a furnace. This divergence raises critical questions about the factors that influence planetary habitability and the long-term stability of life-supporting conditions. For scientists studying climate change, Venus serves as a natural laboratory. By examining its atmosphere and geology, researchers can test models of atmospheric dynamics and assess the potential consequences of rising greenhouse gas levels on Earth. Venus offers a stark reminder that even small changes in planetary systems can lead to catastrophic outcomes. The concept of terraforming Venus has captured the imagination of scientists and science fiction writers alike. Transforming Venus into a habitable world would require monumental engineering feats. One proposed method involves shading the planet from the sun's heat using a massive space-based solar shield. This would allow the atmosphere to cool, potentially enabling the condensation of carbon dioxide into solid form. Another approach envisions seeding the atmosphere with engineered microbes capable of converting carbon dioxide into organic compounds. Over time, These microbes could alter the atmospheric composition, making it more suitable for human habitation. While these ideas remain speculative, they highlight humanity's ambition to reshape the cosmos. Terraforming Venus would take centuries, if not millennia, but it reflects a deep-seated desire to turn even the most hostile environments into places of life and possibility. As humanity continues to explore Venus, the planet's legacy grows ever richer. It is a world that challenges our understanding of planetary evolution, climate dynamics, and the boundaries of life. It is a reminder of the delicate balance required to sustain habitability and the forces that can tip a planet into chaos. Venus, the second planet from the Sun, is more than just a celestial body. It is a symbol of both destruction and resilience, a story written in lava flows and acid clouds, waiting to be fully deciphered. As we unlock its secrets, we not only learn about a distant world, but also about ourselves and the fragile world we call home. To understand Venus's present, we must look back to its past, over 4.5 billion years ago, when the solar system was a turbulent nursery of forming planets. Venus emerged from a swirling disk of gas and dust, its core solidifying as gravitational forces pulled material inward. Bombarded by asteroids and comets, it grew in mass, accumulating volatile elements and water ice that would later define its early environment. For a time, Venus and Earth followed parallel paths. Both planets had atmospheres dominated by water vapor, carbon dioxide, and nitrogen. Volcanic eruptions released gases into the air, while primitive oceans formed as temperatures cooled. Venus's surface may have glimmered with liquid water under a younger sun, its thick atmosphere protecting it from the harsh vacuum of space. Yet, subtle differences began to steer the planets in opposite directions. Venus, slightly closer to the Sun, absorbed more solar radiation, creating conditions that made its atmosphere more susceptible to runaway warming. Earth's dynamic plate tectonics and magnetic field helped regulate its climate, while Venus's stagnant crust and lack of a protective magnetosphere sealed its fate. The Sun, often seen as the giver of life, played a pivotal role in Venus's transformation into a fiery wasteland. As stars like the Sun age, their luminosity increases. Billions of years ago, the Sun was fainter, and Venus might have been cooler and more Earth-like. But as the Sun brightened, Venus's surface temperature rose. This heating led to the evaporation of its oceans, filling the atmosphere with water vapor, a potent greenhouse gas. Trapped heat caused even more water to evaporate, accelerating the cycle. Eventually, ultraviolet radiation from the Sun split the water molecules into hydrogen and oxygen. The hydrogen escaped into space, while the oxygen either bonded with surface minerals or remained trapped in the dense atmosphere. The loss of water was a turning point, setting Venus on its path to becoming the hottest planet in the solar system. It serves as a reminder of the immense power of stars to shape the fates of their planets, often in ways that are irreversible. Despite its hostile conditions, Venus's surface is a place of stunning complexity. Its volcanic landscapes are unmatched in their scale and variety. Lava plains stretch as far as the eye can see, broken by towering shield volcanoes and vast fissures. Impact craters, though fewer than on the Moon or Mars, punctuate the surface, their preservation a testament to the lack of erosion on Venus. One of the most striking features is Ishtar Terra, a massive highland region roughly the size of Australia. Rising from the surrounding plains, it is home to Maxwell Montes, the tallest mountain on Venus, standing 11 kilometers above the average surface elevation. Nearby lies Lakshmi Planum, a plateau surrounded by rugged cliffs and rifts, its name derived from the Hindu goddess of wealth and prosperity. Radar mapping has revealed tesserae, regions of crisscrossing ridges and valleys that may hold clues to the planet's tectonic history. These areas, some of the oldest on Venus, offer a window into its past, potentially predating the global resurfacing events that reshaped the planet hundreds of millions of years ago. Landing on Venus presents some of the most formidable challenges in planetary exploration. The crushing pressure, equivalent to being 900 meters underwater, destroys conventional spacecraft within minutes. The searing heat melts metals and damages electronics, while the corrosive atmosphere dissolves exposed surfaces. The Soviet Union's Venera missions stand as remarkable achievements in this hostile environment. Venera 7, the first spacecraft to land on Venus, transmitted data for 23 minutes before succumbing to the conditions. Subsequent missions, like Venera 13 and 14, captured stunning images of the rocky terrain and analyzed soil samples, providing humanity's first glimpses of Venus's surface. Modern technology offers hope for more durable landers. Advanced materials such as ceramics and heat-resistant alloys could extend mission lifespans. Proposed concepts like Venus Surface Platform, VSP, would use thick insulation and innovative cooling systems to survive for weeks or even months, enabling detailed studies of the planet's geology and atmosphere. While the surface is nearly impossible to explore for long durations, Venus's upper atmosphere offers a far more hospitable environment. At altitudes of 50 to 60 kilometers, temperatures range between 20 to 50 degrees Celsius, and pressures are comparable to those at sea level on Earth. These conditions make the atmosphere an ideal location for long-term exploration. Concepts like high-altitude balloons or solar-powered aircraft could revolutionize our understanding of Venus. These vehicles could float above the acid clouds, collecting data on atmospheric composition, weather patterns, and wind dynamics. Missions like these would bridge the gap between orbiters and surface landers, offering new perspectives on the planet's many mysteries. The possibility of future crewed missions to Venus's atmosphere has even been discussed. Floating habitats could serve as research stations, allowing astronauts to study the planet up close while avoiding its deadly surface. Such missions would mark a new era of exploration, proving that even the harshest environments can be conquered with innovation and determination. For millennia, Venus has been a symbol of beauty, love, and divine power. Its brilliant light inspired awe among ancient civilizations, who wove it into their myths and stories. The Babylonians associated Venus with Ishtar, the goddess of love and war, while the Greeks and Romans named it after Aphrodite and Venus, deities of beauty and passion. In many cultures, Venus's dual appearance as the morning and evening star gave it a unique status. To the Maya, its movements were carefully tracked, influencing their calendars and rituals. In Japan, it was known as Kinsei, the Golden Planet, a name that reflected its radiant presence in the sky. Even today, Venus continues to captivate artists, poets, and dreamers. Its allure transcends its scientific significance, reminding us of the profound connection between humanity and the cosmos. Venus remains one of the greatest enigmas of the solar system. Its history, marked by transformation and extremes, offers valuable lessons about the forces that shape planets and their potential for habitability. As we continue to study Venus, we move closer to understanding its mysteries and, perhaps, unlocking the secrets of life beyond Earth. The planet's brilliance in the night sky is a constant reminder of its presence, a beacon of light that has guided humanity for centuries. As we reach for the stars, Venus stands as both a challenge and an inspiration, a world that beckons us to explore, to learn, and to dream. In the modern era, Venus's symbolism has evolved alongside humanity's understanding of the cosmos. Once thought to be Earth's twin, its discovery as a hellish world of extremes has transformed its cultural and scientific significance. Venus now stands as a symbol of both potential and peril, an emblem of the possibilities inherent in planetary evolution and the dire consequences of environmental instability. Artists, writers, and filmmakers have used Venus as a canvas for storytelling. Science fiction often envisions the planet as a place of mystery, danger, and transformation. Early speculative works imagined lush jungles beneath its clouds, filled with alien life forms. More recent depictions, informed by scientific discoveries, portray Venus as a deadly but fascinating world, a place where humanity might one day attempt to survive and thrive despite the odds. For environmentalists and climate scientists, Venus is a cautionary tale. Its runaway greenhouse effect is a stark reminder of the delicate balance required to maintain life. As Earth faces its own environmental challenges, Venus serves as a mirror, reflecting the potential consequences of unchecked atmospheric change. This dual role, as both a muse for creativity and a warning for humanity, ensures Venus's enduring relevance. The exploration of Venus has been a story of triumph, persistence, and innovation. From the early Venera missions to upcoming state-of-the-art spacecraft, humanity's efforts to understand Venus have been driven by curiosity and a desire to unlock the mysteries of our neighboring planet. The past. Venera and Pioneer Venus, the Soviet Union's Venera program, marked humanity's first steps toward exploring Venus. These missions set numerous milestones, including the first successful landing on another planet, Venera 7, and the first images of a planetary surface, Venera 9. The Pioneer Venus missions by NASA complemented this work, providing detailed atmospheric data and mapping the planet's surface with radar. These early missions revealed the hostile nature of Venus, but they also highlighted its scientific potential. The discoveries of volcanic activity, extreme atmospheric pressure, and the possibility of ancient oceans sparked new questions about Venus's history and its parallels to Earth. The present orbital observations today, spacecraft like the European Space Agency's Venus Express and Japan's Akatsuki continue to study Venus from orbit. These missions have provided invaluable data on the planet's atmosphere, weather patterns, and potential volcanic activity. Akatsuki, in particular, has focused on Venus's dynamic weather systems, capturing stunning images of cloud formations and uncovering insights into the planet's superrotating winds. The future, Veritas, Da Vinci Plus, and envision the next era of Venus exploration promises even greater advancements. NASA's Veritas mission will map the planet's surface with unprecedented precision, revealing its geological history and searching for evidence of active tectonics. Da Vinci Plus will dive through Venus's atmosphere, analyzing its composition and capturing high-resolution images of its rugged terrain. ESA's Envision will complement these efforts with detailed studies of the planet's surface and subsurface. These missions aim to answer fundamental questions. How did Venus become so different from Earth? Is the planet still geologically active? Could life exist in its upper atmosphere? The answers could reshape our understanding of planetary evolution and the conditions required for life. Venus has long been a favorite setting for science fiction, capturing the imagination of writers and readers alike. Early depictions, influenced by the limited knowledge of the time, often portrayed Venus as a lush, tropical paradise. Stories like Edgar Rice Burroughs' Pirates of Venus envisioned a world teeming with strange creatures and verdant landscapes hidden beneath its cloud cover. As scientific understanding advanced, so too did the portrayal of Venus. In works like Isaac Asimov's Lucky Star and The Oceans of Venus, the planet is depicted as a watery world, its surface covered by vast seas. Later, as the true nature of Venus became known, stories shifted to reflect its harsh realities. Kim Stanley Robinson's 2312 imagines floating cities in Venus's atmosphere, while other works explore the challenges of terraforming the planet or surviving on its hostile surface. These narratives, though fictional, reflect humanity's enduring fascination with Venus. They offer a glimpse of what might be possible, inspiring future generations to dream of exploring and even inhabiting this enigmatic world. The idea of terraforming Venus, transforming it into a habitable world, remains one of the most ambitious concepts in planetary science. While the challenges are immense, the prospect of reshaping Venus captures the imagination of scientists and visionaries. One of the primary obstacles is Venus's thick atmosphere, which exerts immense pressure and traps heat. To make the planet habitable, this atmosphere would need to be thinned dramatically. Proposed solutions include introducing reflective aerosols to cool the planet, deploying solar shades to block sunlight, or even using advanced chemical processes to bind carbon dioxide into solid form. Another challenge is the lack of water. While Venus once had oceans, they are long gone, and any terraforming effort would require massive amounts of water to be imported from elsewhere in the solar system, perhaps from icy moons like Europa or Enceladus. Though these ideas are far beyond current technology, they reflect humanity's determination to overcome obstacles and turn even the most inhospitable environments into places of possibility. Terraforming Venus, if ever achieved, would stand as a testament to human ingenuity and resilience. As we look to the future, Venus remains one of the greatest mysteries of the solar system. Its story is one of extremes, of creation and destruction, of beauty and brutality. It challenges our understanding of planetary science and forces us to confront profound questions about the nature of life, habitability, and the fate of worlds. For humanity, Venus is more than just a planet. It is a symbol of what we can achieve through exploration, a reminder of the fragility of our own environment, and a beacon of light in the vast darkness of space. Its brilliance in the night sky continues to inspire, guiding us toward the answers we seek and the possibilities we have yet to imagine. The concept of Venus as a once-oceanic world lingers at the heart of its mystery. Billions of years ago, when the sun was dimmer, Venus's atmosphere might have been cool enough for liquid water to pool on its surface. These ancient oceans, potentially shallow but widespread, could have played a key role in shaping the planet's geology and climate. The loss of these oceans represents one of the most dramatic transformations in planetary history. Without tectonic plates to recycle carbon dioxide and moderate the greenhouse effect, Venus's climate became unstable. Evaporating water intensified the warming process, pushing the planet into a runaway feedback loop that boiled its seas away. Hydrogen from water molecules escaped into space, leaving a dry and desolate surface behind. The lingering question remains: could life have existed in those early oceans? If microbial life did emerge on Venus, it would have faced a swift extinction as the planet transitioned into its current state. However, some scientists speculate that extremophiles, microbes adapted to harsh environments, might have migrated to the more hospitable layers of the atmosphere, where they could persist even today. Among the most intriguing features of Venus's surface are the tesserae, regions of heavily deformed terrain that appear older than the surrounding plains. These areas, named after the Latin word for tiles, are characterized by intersecting ridges and valleys that create a checkerboard-like appearance. Radar imaging has revealed that tesserae cover about 8% of Venus's surface, offering a glimpse into the planet's ancient history. The tesserae are thought to predate the massive volcanic events that resurfaced most of Venus hundreds of millions of years ago. Their formation likely involved intense tectonic forces, hinting that Venus may have once had a more active crust. Some scientists believe the tesserae could contain clues about the planet's early climate and the presence of water, as their composition might differ from the basaltic plains that dominate the surface. Studying these ancient regions could provide invaluable insights into Venus's evolution. Future missions, equipped with advanced radar and spectroscopy instruments, aim to analyze the tesserae in detail, unlocking the secrets of this enigmatic terrain. Venus serves as a natural laboratory for understanding the greenhouse effect, a phenomenon critical to climate regulation on Earth. On Venus, this effect spiraled out of control, transforming the planet into a furnace. Thick clouds of carbon dioxide and sulfuric acid trap solar energy, driving surface temperatures to a blistering 475 degrees Celsius, 900 degrees Fahrenheit. This extreme heating is exacerbated by the lack of oceans, which on Earth act as heat sinks to moderate the climate. Studying Venus's atmosphere provides critical data for refining climate models on Earth. It offers a glimpse of what could happen if greenhouse gases were to accumulate unchecked, turning our planet into an uninhabitable wasteland. Venus's fate underscores the importance of maintaining ecological balance and addressing climate change to preserve Earth's habitability. One of the most imaginative ideas for exploring and potentially colonizing Venus involves building floating cities in its atmosphere. At an altitude of 50 to 60 kilometers, conditions are remarkably Earth-like, with temperatures ranging from 20 to 50 degrees Celsius and pressures comparable to sea level. These regions are above the thickest cloud layers, providing stunning views of the planet's swirling atmosphere. The concept of cloud cities involves large, helium, or hydrogen-filled structures that could float in the dense atmosphere. These habitats would be equipped with advanced materials to resist the corrosive effects of sulfuric acid, while solar panels would provide abundant energy. Such cities could serve as research stations, allowing scientists to study Venus's climate and geology while developing technologies for long-term survival in extreme environments. The idea of cloud cities is more than just science fiction. It reflects humanity's determination to adapt and innovate. As technological advances make such projects more feasible, Venus could become a proving ground for the next phase of interplanetary exploration. One of Venus's most puzzling features is its relatively young surface, estimated to be 300 to 500 million years old. Unlike Earth, where tectonic plates are in constant motion, Venus's crust appears static, lacking the continuous recycling of material that characterizes plate tectonics. Instead, Venus undergoes periodic resurfacing events, where massive outpourings of lava cover the surface, erasing most geological features. The cause of these events is linked to the planet's internal heat. Without tectonic activity to release heat gradually, Venus's mantle builds pressure over millions of years. When this pressure becomes too great, it triggers catastrophic volcanic activity, reshaping the entire surface in a geologically brief period. Understanding these resurfacing events is crucial for piecing together Venus's history. They represent a unique geological process, one that contrasts sharply with Earth's dynamic system and highlights the diversity of planetary evolution in the solar system. The study of Venus has far-reaching implications beyond the solar system. As astronomers discover thousands of exoplanets orbiting distant stars, many of them bear similarities to Venus in size, composition, and proximity to their host stars. These hot Earths, or super-Venuses, offer opportunities to study planetary atmospheres and climates in conditions that mirror Venus's extreme environment. By understanding Venus, scientists can refine their models for detecting and interpreting atmospheric signatures on exoplanets. For example, the presence of carbon dioxide, water vapor, or sulfuric acid in an exoplanet's atmosphere could indicate processes similar to those observed on Venus. This research helps astronomers identify potentially habitable worlds and distinguish them from planets that are more Venus-like in nature. Venus thus acts as a bridge between planetary science and the search for life beyond Earth. It teaches us to recognize the diversity of planetary environments and to approach the study of exoplanets with a broader perspective. Despite decades of study, Venus remains a planet of profound mystery. Its thick atmosphere hides its surface from direct observation, while its extreme conditions challenge even the most advanced spacecraft. Each new discovery raises more questions, deepening our fascination with this enigmatic world. Venus's story is far from complete. Future missions will continue to uncover its secrets, shedding light on its geological history, atmospheric dynamics, and potential for life. As we explore Venus, we are not only learning about a neighboring planet, but also about the forces that shape worlds across the cosmos. One of the most intriguing aspects of Venus is its lack of a substantial magnetic field. Unlike Earth, whose molten iron core generates a protective magnetic shield, Venus's magnetic field is almost negligible.